Do we have ANTUNI from Indonesia? If I see well, she is with us. Yeah, just wait some. Okay, and we will start soon our session, second session, afternoon session, first part, and we hope that we will follow our program successfully. And now we are waiting colleague from Indonesia. I see Antony is connected. Let's wait 1 minute more. Antony is here.
Okay.
Okay. We are waiting.
My voice is clear.
Yeah.
Okay. Okay. Because in Yogyakarta is heavy rainy, so maybe I have some connection problem. Okay, but I will try to present my presentation. Firstly, I will share my PowerPoint.
Okay.
Okay. Okay, you see my presentation?
Yeah, we see it.
Yes. Okay. Okay, thank you very much. Good afternoon for all. Firstly, I would say to thank you very much for Prof. Sentas to invite me in this symposium, and also for my supervisor, Professor Muhammad Chalik. I think he is also in this meeting. I will try to present my simple research. Maybe it is very simple, but I will try to present clearly. The title is Student Motivation and Chemical Literacy on Context-Based Learning, a Case of Chemical Bonding Topics. I am from Department of Chemistry Education, Yogyakarta State University, Indonesia. Okay, why we should do this research? We will start by the introduction that we know that all chemistry education is challenged with 21st century skill. This is also conducts from Indonesian system. One of the challenge of century school in Indonesia is the most important is from chemical literacy on science and chemical literacy. Why? Because in Indonesia sometimes the first session is the PISA result is very low from for student in Indonesia, and then we in the school emphasize in concept understanding, but not improve the chemical literacy. This is the reason because the curriculum in Indonesia is sometimes is more much content that should be taught in every level in this high school. I know that the one framework to improve chemical literacy is context-based chemistry listening. In that we should use a context in chemistry learning. You know that because the chemistry is one of subject that not interest for student in Indonesia. So they think that chemistry is very difficult. They have many factors that chemistry is a difficult subject for student. One of them is about the abstractness and more calculation in chemistry concept. And one of the concept is about covalent bonding. Sometimes a teacher in high school just present the definition of covalent bonding. I'm sorry, this is I mean this chemical bonding, not just covalent bonding. This is not make a student less interest to study about chemical bonding. In this case, so we try to implement context-based chemistry learning that with learn by context in their daily life about the application of chemical bonding. Student will be more motivated to study in chemistry, especially in chemical bonding, because he have better motivation, better interest. So we will more enthusiasm in the learning, and because the integrating of context, we suggest a hypothesis that they will have better chemical literacy. So in the last, we hope that after the implementation of this treatment, we get the good chemistry learning. So the research purpose is to investigate the effect of context-based learning on student motivation and chemical literacy related to chemical bonding. This is one picture then my student doing the pre-test. Okay, about the research method, we use a quasi-experimental pre-post design. The research is conducted for grade 10 student for high school in Indonesia, and then we have about 68 student on experimental group, and then 60 student on control group. We have 4-6 meeting because just for the chemical bonding concept. We conduct the experimental group, experimental class to the context-based learning approach that we use for phase. This is what the example from the third meeting. The first phase is contact phase. In the first, student analyze the contact, and for example, this is fertilizer. This contain of potassium chloride. This you know that Indonesia is a big country in. We have agriculture lands, and this is context is very familiar with for student. And then after that, the second phase of curiosity and planning, student discuss the problem about the fertilizer, and then why the I think the the genres of potassium chloride and so on. And then they arrange questions that would be solved. Otherwise, they plan their own strategies to answer their question. And then in the first development, they discuss to find best answer based on their question in previous phase, and solve after going question related to ionic bonding concept. So this meeting is for discuss about ionic bonding. And then still in this phase, one of the group present their result and discussion in class. And then after that, the teacher gave feedback for all the conclusion and the discussion of a student in the class. And then the last phase is about the deepening and connection. Student extended their knowledge to solve another problem, another question about ionic bonding in the other context. For example, in this case, we use the calcium chloride oxide from on swimming pool. So swimming pool, what they will analyze this element, this compound in the daily life. Okay, and then about the about the control group, we use we call scientific approach. This is one of the mandatory approach in Indonesian national curriculum. And then the instrument we use two instruments to collect the data for the main data of the two instruments. We also have observation to their activity and so on. But the main instrument is context-based motivation scale. I adapted from Onan and Ulusoi. They have 20 items, and we really revalidated the scale on other student. And then there are three aspects for the context-based motivation scale: enthusiasm, efficacy, and performance. And then the second instrument is the chemical bonding literacy test. We have 21 contextual open-ended question based on 4 topics. The first topic is about salt consumption and in the context of health, and floor cleaner also in health, and then oil waste about environmental, and aluminum foil related to health context. The group of expert of chemistry education look at the both of instrument and to ensure the validation. Okay, this is to go to the result. The first result is the independent test. Because the motivation is related to okay. I'm sorry, I have some connection problem. Because the motivation scale is related to motivation in context-based learning, so I just give in the experimental classes. This is the result about the chemical literacy. There is a significant difference on experimental and control group. That experimental is better. And then we also analyze about the aspect of chemical literacy about health and affective domain. This is also have a significant difference for experimental classes. But in the next analysis, maybe we should analyze the indicator of health, higher order learning skill. Okay, based on this result, we can conclude that the context-based learning But context-based learning is facilitate students to think more analytical and critical, that made concept highly memorable because they have memorize about the contextual daily life. Okay, and then the next result in this result is the fair sample t-test for motivation on experimental classes. Okay, we have analyzed for each aspect of motivation that there is all of aspects have a significant difference on enthusiasm, efficacy, and performance. And in the totality of motivation aspect also have significant difference before and after the student attend the context-based learning. It means that the use of the live context provides an authentic application of chemistry that makes students feel happy and enjoy in this course. After the course, we make interview for several students, and they say that with starting context in this learning, a student make more interest, and then we develop their curiosity why is a chemical bonding is related to their daily life. Okay, and this is the main point why I think this motivation is better after student do the learning. Okay, and then for the gain analysis, normalized gain for student motivation, the student is this is the good good result is that there is no. I know that it is a surprise for me that there's no high motivation increasing. Yes, but in average there is increase, but not the high increasing. Just medium and low and constant. That means that no increase, and then part of them is decrease. After the learning, we have some interview with the student that have decreased motivation. They answer some of answer. They say that they can correlate the chemical bonding with some context. Some of them that they just know they just know the fertilizer as one a context. No, so this is not affect from their motivation to learning more about the ionic bonding and so on. So I think we should improve the next experiment about why how we connect the contact with the concept of chemical bonding on other concept. Okay, and then we go to the last result is about the pair sample test of chemical literacy on experimental class. We analyze for every meeting. We have 4 meeting. One is about ionic bonding. We have context about salt concept consumption, and then in the second we have covalent bonding is fluor cleaner, and then we use a context of fluor cleaner, and then in the third we have compound polarity. We use context oil waste, and then metallic bonding. The context of the concept of metallic bonding, we use context of aluminum for foil for food. All of the context in the chemical literacy test also give the different after and before they learn about the chemical bonding. And then the last of about the analysis for student chemical literacy. There's also still a decrease of chemical literacy for the student after and before, and then for high there's just maybe for the third part of them have a high increasing in chemical literacy. Okay, I think this is just for simple research for us, and then the conclusion is context-based learning makes students enjoy and get meaningful learning, so affect their motivation. And then context-based learning facilitates students to think more analytical and critical in increasing the chemical literacy. And based on the research, we recommend that context-based learning as one of way to increase chemistry learning quality, especially for Indonesian context and for the abstracts or maybe this is no more calculation concept in chemistry learning. Okay, I think this is enough for my presentation. Thank you very much. Good afternoon for all.
Thanks, Antony. We have enough time. I'm so sorry because it's a small mistake and we allocated accidentally longer time for your presentation, not 12:50, but 1:20. But never mind, I would ask next presenter, DUŠICA RODIĆ from Serbia. She will have longer time for her presentation, but now hello, DUŠICA. You will have more time because we should keep our time frame. However, I see now that we accidentally allocated for Antony. We respect Indonesia. We allocated longer time. Never mind. I want to ask because it's, oh my God, it's my favorite chemistry. It's my favorite area. And this is really, from one side, we see a lot of similarities. First of all, for example, you mentioned that students do not like chemistry or not so interested enough in chemistry in Indonesia. But the same in Lithuania. I hope so, more or less the same in Serbia. Do you know at least one country where students are happy with chemistry? I am not. Okay, let's be more precise. I fixed one term you used in your presentation, efficacy, right? I have some doubts in what do you mean by efficacy? Why not effectiveness? Okay. I know that these terms, both terms are somehow similar and close to each other, but however they are different. What we are really measuring, efficacy or effectiveness?
Okay. I mean, in this research, efficacy is just one of aspect of motivation scale. So related to the confidence, the sure of student to learn chemistry. Efficacy is one of aspect of motivation scale.
Why not effectiveness?
No, because related to the student feel that they are sure that they can pass the chemistry learning, they get the good mark, not related to the implementation of something.
Usually, if we have, let's say, for example, some activities or performance, etc., or process under something like intervention, for example, during experiment or something like that. Under ideal or at least controlled circumstances. In this case, we can use the term efficacy because efficacy refers to the extent of something. And effectiveness refers to, for example, to its performance under real world conditions.
Okay.
Yeah, this is because it's just interesting also for me because quite often we use different terms and I just wanted to ask about that. Maybe more questions for Antony because it's really interesting.
Yes, can I ask a question?
Yes, please.
Okay, first I would like to congratulate Antony for a very nice and inspiring presentation. I think that context-based items and tasks are really important and a good thing for chemistry education. And I would just like to hear your opinion about, I don't know if you have tested the cognitive load while doing these tasks related to like context-based tasks. And did you encounter any kind of difficulty, for instance, with the reading? Because you can find in the literature, for instance, we have recently conducted a chemistry competition, and we had some tasks which were context-based, and we have noticed that a lot of students had a problem. They struggled with the context-based items, and their teachers told us that the problem is the reading. It's a lot of information inside the context, and that is a problem for students. What do you think? Could you reflect on that? Thank you.
Okay, thank you for the nice question. I very agree with your opinion and suggestion. Sometimes students have difficulty in reading, and I know that get the relevant information from the text and context-based learning. So I think in my worksheet, in the first step, students should write what the information that they get from the narration of the text. But in this presentation, I have not present this one. And this is a good suggestion for me. Maybe after that, I will look at again the student answer, and maybe we can make the other data analysis. Thank you very much.
Thank you.
I see one more question in conversation window. Please have a look at conversation window. I think this is from Muammer. One question for you.
Okay.
You know, your mentor is so strong.
Yeah, but he have promised to me to not give me a question. But
yeah, but
yes,
question.
Yes.
Okay. Question is here.
Okay. Thank you for the question. Yes, I know that this is a very the one of limitation for my research, that for just 6 meetings is not enough to prove that the motivation is increased or decreased, because motivation is the self. I know this self depend of the self and experience, and then maybe depend on the time they contact with something. So I think this is one of the limitation of this research.
Thanks, Antony. It's really good. One more question, because it's also interesting. You, at least in your title, not on the title, students' motivation and chemical literacy. Can you explain shortly or enlarge this construct, chemical literacy? What do you mean by chemical literacy?
Okay, chemical literacy. I use the concept from SWOT. There are several aspects. We use the context, and then we use the high learning order learning skill, and then also affective domain about the interest of the context. So I mean, in the chemical literacy is they look at the concept with the higher learning skill or the learning skill, and then they saw the interest for the context in their daily life, and then the context is served as an environmental, and sometimes we use the impersonal, their daily life and social dimensions like that.
Yeah, but you see that we have a lot of literacies, let's say, yes. Biological literacy, chemical literacy, physics literacy, science yes. literacy. Yes. And for example, how it's connected or interrelated with science literacy, for example, for particular person, he or she, I am scientifically literate or not? How to...
Yes, I think this is the part of scientific literacy, because I focus on the chemical concept, chemistry learning. But in terms of the context, like a fertilizer like that, this is also contains scientific literacy, because just not a chemical concept in this context. But I just measured the context of chemistry concept.
I'm not sure if you were able to follow first plenary presentation by Malgorzata about some myths in chemistry. Yeah, and not only myths, chemical versus natural common misconceptions, and it was really possible to observe that, let's say, different literacies combining together. Yeah, we need something from chemistry, biology, let's say, real life in general, and it's really integral thing, integral phenomena. Yeah, I see colleague from India joined us. Okay, thanks. Thanks, Anthony. We have more time for questions. Please, this is very good possibility to make a lot of questions to Anthony, because we have enough time for questioning. No more questions? No. Okay, thanks, Anthony. I think you will stay with us for this day. Okay. And next presenter, colleague DUŠICA RODIĆ from University of Novi Sad from Serbia. And you have more time. 40 minutes. Yes, 40 minutes.
Okay, try, but I don't think that I have prepared enough slides for that. But
yeah, but you know, this is our life, unpredictable life.
Yes. Yeah. And we will also have a lot of time for discussion, I think so.
Yes, okay, okay. I hope that your presentation, let's say, will be so interesting and we will raise a lot of questions.
I hope so. Okay, I will try to share my screen. Okay, can you see the slides? Actually, the title slide now?
Yeah, it's okay. It's okay.
Okay, and then I will start. Thank you once again. First of all, I would like to greet you all from the city of Novi Sad, Serbia, which you can see now on this slide. I have to say that I'm sorry because we were not able to attend this conference in person this year and to visit again beautiful Lithuania. However, I believe that this will be changed until the next conference. And I also would like to say that I appreciate this opportunity to meet with all of you online. And I would therefore like to thank all the organizers, primarily Vicentans, who made it possible. I will introduce myself. I'm DUŠICA RODIĆ, and I am Associate Professor at the Faculty of Sciences, University of Novi Sad, Serbia, and I work in the field of chemistry education. And therefore, my presentation today is going to be built around chemistry, but I think that it will also be interesting to those who work in the field of science education, because I will talk about algorithms and algorithmic approach, and I believe that algorithms are present also in biology education, mathematics education, physics education, and so on. So till the end of the presentation, I will try to answer the question, to what extent do students rely on an algorithmic approach when it comes to quantitative problems in chemistry? So for the beginning, I would just like to give you a brief introduction. Peter already mentioned the conceptual understanding and importance of conceptual understanding. So I would just give you a brief introduction. I would say that conceptual understanding is a key component of chemical expertise, and thus may be one of the most desirable outcomes in chemistry education. But on the other side, there is different reality. We are aware that students are prone to use algorithms to memorize rules, definitions, and procedural steps. Actually, they do not engage enough in development of conceptual understanding. Why is it so? Well, we can offer several possible explanations. First of them is probably that students find chemistry difficult because it involves too many calculations, and thus it resembles mathematics. We yesterday could hear that mathematics is usually considered quite abstract and difficult. But we can say the same for chemistry, because there is a lot of calculations really, and the problem is Actually, the ANTUNI gave me a nice introduction for the thing I'm going to talk now, because I believe that the huge problem in chemistry education with calculations, primarily, I can say from the perspective of Serbia, but I believe that the same can be said for other countries. The problem is that quantitative problems commonly contain only the data and the request without the proper context. And that's why students do not comprehend the purpose of solving quantitative problems. They actually cannot grasp the relation of that calculations with everyday life, with pharmacy, with medicine, with industry. It would be much better if the items contain the context so the students could understand why these calculations are important and why these calculations and how they are related to their everyday life. So we can say that the use of algorithms in teaching and learning in this sense in chemistry is not something that is quite desirable. And that is why it is becoming very important to develop new ways of probing the reasoning that underlying students' mathematical problem solving. And that is why we set the aim of our research to examine whether the students have a mechanical or conceptual approach to solving quantitative chemistry problems. And we decided to start from our own institution, from the Faculty of Sciences at University of Novi Sad. We wanted to test first our students. And I can say for our university, it is a large university with around 50,000 students. However, we don't have a lot of students that are interested in chemistry education, who are majoring in chemistry education. And we wanted to have our first sample to be those students who are majoring in chemistry education, who will become teachers in a year or two. So we have around 10 in that period when we conducted research. It was 2016-17 and 2017 and 18. We had around between 10 and 15 students a year. And that's why we've decided to include 2 generations in order to enlarge a little bit our sample. So the total sample was 22 students. It's not a big sample, maybe enough, but I would say that the number of students, it wasn't very important for our research. That was, I would say, practically qualitative nature. I also want to say that this research is part of the larger research. We also included eye tracking analysis, and when you do eye tracking analysis, it is extremely time consuming, and that is why we didn't have a huge number of respondents. However, we included 2 generations, and we consider that our sample is adequate for this type of research that we have conducted. So these are the student teachers who were in their final year of the bachelor studies, preparing to become chemistry educators. As research instruments, we used 2 tests. The first test was declarative test of knowledge. It was aimed to examining declarative knowledge through multiple choice tasks. And the test contained only 4 questions with 4 options, and 1 was always correct option and 3 were distractors. This is the example. This is quite simple items that our test consisted, and you will see a little bit later on why we used this kind of questions, because I'm going to compare them to the questions from the next text, which was actually the main instrument. So this is the example. Which answer includes all the following that are insoluble in water? Circle the letter of the correct answer. Okay, the next instrument that we use is the main one, and it contained 5 quantitative problems, each of which contained information that made calculation, well, I would say maybe nonsensical, or actually it contained some kind of tricky information. For instance, this is the example of one such task. Calculate the molar concentration of the solution obtained by adding 15 grams of silver chloride to 15 cubic centimeters of distillated water. So what we expected actually here, as you can notice, we gave the tricky information here is the silver chloride. And we gave them here the blank space with to write the procedure and to write the comments. They were encouraged to explain their procedure. If they don't know how to perform the procedure, we asked them to write it down. Why is it so? Do they lack if maybe they don't know the formula, maybe they lack the data, or they think that something is wrong with the item. We ask them actually to reflect on it, to read the item and to reflect on it, or to write the part of the procedure they are able to do. Also, if they don't know how to if they know how to perform the item, then to write down if it was easy for them, was it complicated for them, why it was difficult, why it was easy. Actually, we ask them to reflect on this item. Here are the results of the first test. And these results were in a way expected, because the first test was measuring actually declarative knowledge. The tasks were quite simple, and we expected students to be able to answer all of them because they were in their final year. The tasks were constructed in a way that everyone who is in their final year certainly will perform good on these items. We only can see here that there is only one item number 3, that was scored with partial success. All the others, we had a very high performances, which was in a way expected. And now if we discuss the results of the test number 2, you will see why we needed the previous items that I mentioned. Calculate the molar concentration of solution obtained by adding 15 grams of silver chloride to 15 cubic centimeters of distillated water. So first we wanted to check if students know that silver chloride has a low solubility in water, and that was the case actually, because the performance in the generation 2016 and 17 was 100%, and the performance in generation 2017-2018 was around 19%. So it means the students know that information. They have that declarative knowledge that silver chloride is insoluble in water. However, when it comes to the calculations, we actually wanted to see if students are able to notice that if the task is given in this form. We wanted to see them reflect on that, if any one of them is going to write it down, to comment on that. But actually that was not the case. As you can see, that is one actually usually practice with them this kind of tasks, like calculations. But we always give them the compound which is highly soluble in water. So in this particular case, majority of students answered in this concrete way. So they had the mass of the silver chloride. Then they tried to first they have converted the mass into the number of moles. When they have calculated the number of moles, they have calculated the concentration by dividing the number of moles, actually the amount of substance with the volume, and they obtained the results. And none of them, we expected that some of them will notice that the silver chloride is insoluble in water and that will make a comment, but that was not the case. This was one of the most often answers that we encountered when we reviewed the items. The task is easy, one just needs to know the formula. I will show you 2 more examples. I know that you heard a lot of chemistry yesterday and today, but I'm going to add a little bit more. The item was, what is the pH of a solution formed by addition of 0.1 mole of aluminum to 10 cubic decimeters of water. Again, we wanted first to check if students know that aluminum is the metal that does not dissolve either in hot or cold water among these that were given. And that was obviously the case, because we had performance of 100%. 100% of students answered it correctly, and in next generation 0.19, so it means 90% of students. However, again, when it comes to the calculations, they completely ignore this type of information. None of them has even mentioned that in this item, and they immediately start to search for the appropriate formula to perform the item. So what they try to do first, they had the number of moles of aluminum. Then they first, having that information and having information about the volume, they first calculate the concentration of aluminum hydroxide, then calculate the concentration of hydroxide ions, ions. Then, knowing the ionic product of water, they calculate the concentration of hydrogen ions and then calculate the pH value. Actually, and none of them noticed, and none of them said that aluminum won't dissolve in water and add additional hydrogen ions. So this was also one of the common comments. The task is easy because the concentration of hydrogen ions is practically given. And knowing that, we just have to calculate the concentration of hydrogen ions and then the pH. And the last item that I want to show you, what is the volume of carbon needed to react with the appropriate amount of oxygen to produce 2.24 cubic decimeters of carbon dioxide? Circle the letter of the correct statement. Here we had first, of course, wanted to check their declarative knowledge, if they know that, if they are familiar with the number 22.4, which can often be found in various data booklets. If it relates only to the gases, and they knew that in high performance is 0.9 and 0.7. So majority of students possess that declarative knowledge, but we wanted to see if that declarative knowledge could be functional, could it be used in a situation such as this one. We give them carbon, and which is under standard pressure and temperature in a solid state. But somehow they again neglected that information that carbon is not a gas, and they started to calculate in the same way. First, they calculate the number of moles of carbon dioxide, and then using stoichiometry and the chemical equation, they calculate the amount of carbon. And then we expected that some of them, when they come to this point, when they calculated the number of moles, we expected them to write down to comment that they can calculate the number of moles, they can turn it into the mass, but we expected that some of them will say we can't calculate the volume because we don't have the data about density, or we don't know which allotropic modification it is, and so on. But none of them has actually noticed that, and they started to calculate in the same way as the carbon was in a gaseous state. They calculate, since they have calculated the number of moles for carbon, they multiplied it with a molar volume and obtained, of course, the wrong value, with a comment that through proportion and by applying the formula, it can be solved very easily. And what we actually noticed when we reviewed all the comments, there was something in common for all of them. All of them actually mentioned formulas. For instance, the task is easy, one just needs to apply the formula. The task is easy if you know the formula. The task is not a problem if the formulas and the value of molar volume are known. Extremely easy because one just needs to substitute known variables into the formula. The task is easy because by applying the formula, it can be solved in one step. So we can actually see here that they are very confident in their knowledge, even though they are wrong. And actually, we have noticed that we are preparing them. We practice with them too much with some kind of knowledge that is not very useful. We drill them to know to perform all the items, and then they do not understand the underlying concepts. Even those who are not able to remember the formula, they mentioned who were not able to provide any kind of solution and procedure. They brought also, I can't remember the formula, I'm not sure if I used an appropriate formula, the task is not difficult, but I can't recall the formula, or maybe this one is the most important, the last one. I can't calculate because I haven't used that formula for a long time. Because these type of items are, according to our curriculum, are usually performed in the first year. Within the general chemistry, and then they were in their final year, fourth year, and it means that knowledge that they have is very declarative and non-functional, and they start to forget it, which means that we drill them, but we don't provide them to understand good, and that is what is quite worrying. So I would like to make some conclusions. So, like, based on the results of the test number 1, we concluded that students have certain declarative knowledge, which is unfortunately not very functional. All of the students who tried to resolve the task from the test number 2 were using formulas and algorithms, and none of them have noticed the concepts that made the calculation nonsensical. None of them has noticed that tricky information that we give in the items. And based on students' comments, we could conclude that students do not pay enough attention to the underlying concepts. And that is, I believe that is not only a problem in chemistry. That's why I said at the beginning that I believe that the same problem persists also in physics education, in biology education, in mathematics education. Students are just prone to use algorithms. And I think that maybe we could improve the situation with a saying less is more. Sometimes we can actually, we don't have to perform 10 items during the class, but we should talk more about them. We should reflect more on the context of the item and reflect more on actually the underlying concepts beneath the text of the item. Okay, that's all that I have prepared for today. Thank you very much for your attention.
Thanks, DUŠICA. It was really nice. Maybe we have some questions, colleagues, please. It's interesting. Chemistry always is interesting.
Yes.
Yeah. Just one simple question. You mentioned this concept as declarative knowledge. If I understand well, it usually means like basic knowledge, right?
Yes, and actually knowing the facts, knowledge of facts, something like that. Yeah.
Or basic knowledge, maybe.
Basic knowledge, yes, yes.
Basic knowledge about something, about some concept, some chemical phenomena, etc. And what about, let's say, next level, procedural knowledge, for example, deeper knowledge?
Yes, it is important. That is maybe the problem, because with our curriculum supports that kind of. I don't know if that is the case with other countries, but in Serbia, for instance, we have a lot of calculations in primary education, secondary education, tertiary educations, but they usually measure some lower order cognitive skills. And I believe that should be changed. And maybe, well, Antuni made a nice talk with the context. I believe that can be changed with items like the context, because I think that you just need to involve students to understand how it's related to them, and then they will activate more and they will understand it better.
Mm-hmm. So we have some like comments, not questions from Lucas in relation with physics. What do you think?
Yes, I think yes. I believe I mentioned at the beginning that it's not related only to chemistry. I believe that it can be also applied and tested also in physics, and I believe that the results would be quite similar in physics also.
More questions, colleagues, more questions. Please be more active. I know that it's hot, at least in Serbia and Lithuania.
Yes, 37 here.
Oh my God. Yeah, but anyway, we should continue somehow. It's yeah. Okay, and just maybe a close question. What about chemistry teachers? I have in mind pre-service chemistry teachers having in mind their preparation, etc. What do you think? Because you know, we see the similar problem. Chemistry is difficult. Chemistry is boring. Is not interesting, etc. etc. Why finally? It's
I don't know. Malgorzata mentioned one thing. It's not only the chemistry, but I would say about the chemistry teachers. We don't have enough students who want to become chemistry teachers. It's common problem. I believe it's not only about Serbia. It's probably everywhere. But in Serbia, like in the Poland, we also have the problems with the salaries. It's not very popular to say, but there are a lot of teachers who are enthusiastic regardless of the salaries. But for many, salaries are important, and they are somehow humiliated in the society. You know, they are not respected enough, and that relation to teachers in society should be changed, and then probably we would have more students who want to become teachers, because I really believe that vocation is something really special.
Thanks, DUŠICA. Just in addition, for example, if I remember well, maybe 2 years or let's say 2-3 years ago, Vilnius University in Lithuania prepared new study program for bachelor level, so-called integrated study program, combining chemistry, biology, and physics, like 3 channels together. And but the idea was to have a common integrated program and somehow to prepare an integrated teacher of science. But I was an expert for this program. This program successfully passed the expertise procedure. Everything was fine, but now nobody entered. No candidates.
I completely understand that, because we had the similar program maybe 10 years ago. It was also evaluated by various experts, and it was approved. And we had maybe each year we enrolled maybe 1 or 2 students on that program. And we had a problem with the ministry. They actually didn't change the regulations, and those students could never find a job. Now we don't have that program anymore. We have each subject is each program. You know, we have integrated studies of chemistry education that lasts 5 years, but also interest is not very high, unfortunately. We can just hope that will change.
I'm not so sure, let's say, or so optimistic, because young generation, it's everything should be easy. Everything should be easy and should be fun. Why to put a lot of efforts to study chemistry or physics?
Yes.
Okay, biology maybe, but okay. Thanks once again. And I see our next colleague from United Arab Emirates here with us. You can start also, and you will have also a little bit more time than allocated before, because due to the first presentation. And you can start, please.
I want just to share. So do we have the right to share?
Yes, of course.
Okay, just a second, please. So just 1 second. No. Okay. Can you see now?
Yeah, it's okay. Please full view.
My file is clear.
Yeah, but full view. You can switch on full view.
Full view, yes, I can. Just a second. So full view. Mode and écran. This is French, so.
Below, you see this icon below at the bottom.
Yes, but yeah, I have it now. How about now?
Oh, it's the same. It's not full view.
Not full view? Okay, so I'm sorry because
F5.
F5. On my screen, it's full view now, like that. On my screen, it is. How about for you? It isn't?
Oh, at least for me, it's not full view. But anyway, you can continue.
Okay, I'm sorry. So let me see what is the problem. Just 1 second, please. Stop sharing. So again, desktop window. Still the same?
Oh, now it's okay.
Now it's okay.
Yeah.
Okay, so good afternoon, everybody. Voice is clear?
Yes.
Yes. So I would like at the beginning to thank the organizers of this symposium for giving me the opportunity to make this presentation and share my thoughts and my experience on geometry teaching and learning. My name is NAFAA CHBILI. I'm from United Arab Emirates University. I'm a faculty member at the Department of Mathematical Sciences. My research area is indeed geometric topology. So I have interest in teaching geometry in particular. So my presentation is outlined as follows. I will start by an introduction where I talk about some issues in the teaching of geometry. Then I will explain the context of a small study that we carried about project-based learning as a remedial action to certain learning outcomes, and we will make a brief conclusion. So the main objective of today's lecture is to investigate how the attainment level of specific course learning outcome. So we are working in an environment where we use outcome-based education. We follow a model of outcome-based education. And what we want to study is how the attainment level of a certain course learning outcome is changing with the change of instructional methodology from traditional, conventional to project-based learning. So this study concerns geometry and the graduate course, and it concerns a specific outcome. It's not general then. So geometry, I think most of people here are scientists. We know what is geometry, a fundamental branch of math with important applications in many fields of science and engineering. And you know all, and I'm sure almost everybody knows the importance of the geometry as it contributes to helping students develop the skills of visualization, critical thinking, intuition, perspective, problem solving, conjecturing, deductive reasoning, etc. It is geometry is taught at all levels of curricula. This is another proof that it is so important in all levels of curricula, so from primary to graduate schools, and generally axiomatic geometry, which is our subject today, is taught at university and the graduate level to students in different measures, especially in science, engineering, and education. So teaching geometry is challenging and controversial, if I have to summarize this. So challenging because you can read here from Jones and Fujita. So deciding how to teach geometry remains a demanding task, with one of major arguments being about how to combine the intuitive and deductive aspects of the geometry into an effective teaching design. It's controversial because there is no, like any other maybe field of education, it is controversial. There is no agreement about one most effective teaching approach, and it is still in the investigation, and there is research work ongoing about the teaching and learning of geometry. So what is the main point? So if from my experience, although this course is taught at the university, is that the geometry is not computational, and this is the main difficulty that students are facing. So if we are studying algebra, we want to solve an equation like this, there is an algorithm that we follow. So students know that there is some machinery that they follow and they will end up with the solution. So there is an algorithm. So something that can be done by computers indeed. In geometry, if you look at this a small picture here and this figure, and here is a small problem. Show that the length of CD is the length of BE given that these triangles are isosceles. It is very difficult for students. Whenever I ask students a question like that, the problem is they say, we don't know what to do. We don't know from where to start. There is no algorithm to follow. So each situation has a different approach to solve. And this is the main difficulty that students are suffering from. So rather than the memorization of simple algorithms to solve equations by rote, it demands true insight into the subject, clever ideas for applying theorems in special situations, as it was observed by Artman, as you can read here. So one of the models that is famous models in geometry teaching and geometry is the theory of Van Heel, the couple Van Heel. So this Van Heel model, it divides the levels of thinking stages in geometry into 5 levels. So level 0, which is visualization. So this is what students start with at primary school. Analysis in the second level, level 1 here, to analyze the situations. Level 2 is informal deduction. Level 3 is formal deduction, and level 4 is rigor, when students understand the axiomatic geometry and can move from one theory to another. They can write rigorous and complete proofs of some results. And these model also, these levels, they have properties that are well known in this Van Heel theory, fixed order. So these 5 levels should be are attained in order. They're adjacent to each other, so we want to move from one to the other, and what was at some level in the first order will be improved in the next one. Distinction, each level is distant from the other. Separation and attainment. So separation is another challenges that education are facing. So separation in this theory, it means that if you have students in different levels, so they cannot understand each other. So it makes things very difficult for the educator, for the instructor, for the teacher to talk to people in different levels. And this is something special we face at the university, because at the university we suppose that students are at the final level, which is the rigor. But if you have students still in the third or the second level, then it will be hard to put this group together and to work with all these students which are in different levels. So if I make an assessment, so this is something that I do whenever I teach this course. So I try to assess students' levels, reasoning levels at the beginning of the semester. So what is supposed, I suppose that students are these fresh undergraduates in science, engineering, and education. They are supposed to master at least the first 4 Van Heel levels: visualization, analysis, informal deduction, and deduction. So they are supposed to be to attain these levels without any problem. But is it the case? So if we do a small assessment for these students, which are majoring in science, engineering, and education in general, so what we denote is that there is a low performance in questions related to level 3 deduction and very low in level 4. So level 3 and level 4, there is a big problem there. And the number of students also, because if we have a large number of students, some of them we will face will be at level 2, even at level 2, or which is abstraction. They still have problems with abstraction. So another thing is that what I realize is there is the absence of a concept map. So students, they have some knowledge, but these knowledge are not well organized, not related together. So if I generally ask students in the first lecture, please take a sheet of paper and a pencil and write all what you know and from what you remember from geometry. So they will write few things, but they are mixed, okay? They don't know what is a definition, what is a result, what is an axiom, what is a theorem, how to move, at least from the very basic ones. So we are working in outcome-based education. So this means that the curriculum and pedagogy and assessment are focused around students' learning outcomes. Each student is supposed to attain a predefined list of intended outcomes by the end of the semester or at any point during the semester. So this is, you know, maybe you are all aware of the benefits of this model. So since I don't have much time, I will go to the objective of this study. So the main objective of today's study is to investigate how the attainment level of specific course learning outcome is changing with the change of instructional methodology. So this is what I explained at the beginning. Now I will move to the context. Can you hear me clearly? Because can you hear me?
Yes.
Okay, thank you. So geometry, so the course that we will be working on is the geometry course, a 3-credit-hour course. It covers subjects ranging from Euclidean planar geometry, the high school geometry, classical geometry, to more advanced topics such that hyperbolic geometry, spherical geometry. But in general, it is axiomatic. So it is offered for science, engineering, education students. So usually I have a group of students, which are, some students are in math and physics, or in chemistry taking math as a minor, many students of architectural engineering, and some education students, pre-service teachers, okay, where they who believe that this course is very important for them, and I do so. So the course learning outcomes for this course has 6 course learning outcomes. So this course learning outcome, you all know, maybe is a formal statement of exactly what students should be able to do after completing the course or at any specific time during the course. So we have 6 learning outcomes which are all assigned the same weight. The direct assessment tools that we use to assess these outcomes are the tests, quizzes, assignments, projects, and of course, the main portion is the final exam, written final exam. And we sometimes use indirect assessment tools, which are mainly the students' survey. We survey students about their mastering of these outcomes. So this table, it explains these 6 outcomes and how they are assessed, as you can see here. So I'm interested in the one in red, which is course learning outcome 3. So all what we do is related to this outcome, this specific outcome. So let's know more about this outcome. So the initial observation is this course learning outcome 3, which is geometric construction. So construct geometric figures with ruler and compass. So the initial observation is that after first semester we offer this course, we have seen that there is a low performance in questions related to this outcome, because each question in each assessment, in the test or in the final exam, each question corresponds to some outcome, and the questions which correspond to this outcome 3, there is a low performance there is low performance of students. So this outcome is related to solving skills, critical thinking, and I think it corresponds mainly to Van Heel level 4, because students, they should do things in a very rigorous manner. So after a first remedial action, after we notice this low performance, we decided to work on this outcome, so to give more time, more examples, more discussion time in the class to cover this topic. After the second semester, there was no significant improvement in students' performance, although we have other batch of students, but still it is not, we are not satisfied of this performance. Again, one more time, we give more assignments, take-home exams or take-home assignments, but there is no significant improvement in this third semester. So we decided to try to introduce this part of the exam, this part of the content or this part of the course, which is geometry construction, students should master in a different way using a different learning method. So we opted for project-based learning. Everybody, I'm sure, is familiar with this project-based learning, so I will not go through the details. This is the definition, the goals, etc. But I would like to say a few words about project-based learning in undergraduate mathematics. So this is important. There are several studies indeed in literature which show that project-based learning improves students' learning and their positive attitude toward math and science in general. So augmenting math courses by project-based learning is beneficial for students. It motivated students. Some work have been done, in some work published in International Journal of Engineering Pedagogy. However, this project-based learning is still not very common in undergraduate mathematics. So we are teaching many courses, and in some courses you cannot use project-based learning. It's very difficult to implement. It's not easy to implement because real-life problems, they involve a wide range of knowledge. This is, I think, the main obstacle is that if you want to use project-based learning in geometry course, maybe students will need some knowledge in physics or some knowledge in engineering, and this is not always the case for a small project like that. However, we use PBL in capstone courses or at the graduate level. It is easier because students has built some knowledge, and he's at the end of his learning journey. So at that time, it is easier to implement project-based learning. So what kind of projects we suggest? So it's a construction project. So we want to train students on construction using a ruler and compass with all the theory behind that, of course. So this is a sample of project. Is we ask students to construct basic geometry figures first, then we give them more challenging constructions. We ask them for more complicated constructions. We ask them to create a creative design, so a new design using the ruler and compass. So here we'll test their innovation and how do they master this technique. And we ask them, of course, to explain all the steps and to just justify all the claims. So all the proofs, rigorous proofs, should be written, and steps should be explained, and there should be some innovation. They will suggest a new design. It might be artistic design, it might be engineering design, but using a ruler and compass. So the assessment, so we assess the students as usual in two ways: by their reports, the presentation of the reports, and also we assess this course learning outcome in the final exam, written as if they are taught in the classical way. So this outcome, there will be exam, there will be question in the final exam about construction, and you can see that it will be allocated 12 to 15% of the final grade. And we also survey students at the end, after they make their presentation. We survey students about the achievements of the 6 outcomes. May I know how much time do I need? Do I still have? How much time is left?
We have 10 minutes.
Ah, more 10 minutes. Okay, I thought it is less. Okay. So then now we will look at project-based learning versus conventional learning. So what the data I'm gonna present now, I will only present data related to the level of achievement of this outcome. I will not look at the other outcomes. So now for my university, the course outcomes, they have an attainment level. So what is the outcome attainment level? Is defined, so this is general, is the percentage of students who score 70% or higher. So for each outcome, we check the attainment level. So how many students, what is the percentage of students who scores 70% or higher in the question is related to that outcome. And when an outcome is considered as attained, so the outcome is attained if 70% of students score each 70%. So I need 70% of my students to score at least 70% in the questions related to this outcome to say that we are satisfied with what we did and that the outcome is attained. So we have to generate some reports to make some statistics which show that outcomes is satisfied or not. If it is not satisfied, we have to write something to explain or to give some recommendation how to improve students' performance. So I just show you a little bit what happened in the first semester. So after semester 1, you can see the number, the percentage in red here is the percentage of students who score 60%, 70% or higher in this outcome. In some question in test 2 or in the final exam, you can see 58% scored more than 70%. So the outcome is considered not attained. So the attainment level is 60% in total for this semester. For the second semester, after we take some action, there is no improvement. Even the attainment level is 50%, but I have less students, only 14 students, so we cannot really make a conclusion. After that, we enhance the action, which is to allocate more time, to give more assignments, to more discussion in class, and there is no significant improvement. We have a 65%, so still less than the attainment level which is required by the school. So then I will go to the next semester. I was lucky, I have 2 groups of students. I have 2 sections, and in one section I have about 18 students, in the other I have 20, and I decided to check. I will use different teaching methods and see. So this is very classical. So for the control group, I use a conventional learning. So I do as usual. So we teach using the smart boards and using the. So this was before the online indeed. Okay? We teach using smart boards, whiteboards, using PowerPoint presentation. We use a lot of. We can use a lot of some softwares to illustrate things. And so for outcome 3, after the final exam, I look only at the questions in the final exam, which are about the same. So I have 66% of attainment level. So 66% of students, they attain the level, so they score more than 70%. However, for the group that were taught using this, who learned this construction using the project-based learning, I had 20 students. Only for outcome 3, we use different instructional methods. So the achievement level was about 75%. So there is some difference, as you can see, in achievement of outcome 3. But now if I look at the other outcomes, there are 4 more outcomes, but I assessed only, there are 5 more, but we assessed that semester only 4 of them. So the average level for the control group is 71%. However, for the experimental group is 73%, but they were taught using the same thing. So the only difference between the 2 groups is that material related to this construction was done using PBL in the experimental group and using the traditional means in the control group. So for the other outcomes, they are almost the same. However, there is some difference when it comes to outcome 3, which was done in different ways. Okay. So I can make some conclusions then. What are the conclusions? So the direct assessments, they provide some evidence, small evidence of course, not enough, but that PBL has been more effective than conventional learning in achieving this particular cross-learning outcome. This is my first conclusion. I also surveyed students, and when students have been surveyed, so we asked the students before the exam, last week of the semester, we have a survey that we ask students, what do they think? How do they evaluate themselves about all the outcomes, in particular about outcome 3. So what I found is that experimental groups, students who use project-based learning, they feel more confident. They feel more confident than those in the control group. However, about the other questions, it is about the same. About the other outcomes, they feel about the same. Okay, but there is a difference. This PBL made the difference. So students, they feel better toward this outcome. So there is no evidence that this will work in the same way if I apply it to the other outcomes. Maybe this is specific to this construction because it is multi-steps and it requires some, maybe some good knowledge of the subject and to be well organized in writing the steps and writing the proofs, etc. Maybe students, they put more time also. So one more thing is after we collect more data, a more interesting study will be to consider the changes in the level of achievement according to students' major. We have students in math, engineering, and education, and I have some initial observation about which one feel better or with this project-based learning. So we have some initial observation, but it needs to be confirmed. So the students, they learn better using this project-based learning in engineering. This is my observation, but it needs to be confirmed. Okay? I don't have enough data to go further and make a solid conclusion. Okay, so I have some references, maybe can share later. Thank you very much. I think I'll stop here. It's about time. Thank you.
Thanks, NAFAA. It was really also interesting, obviously. Please stop sharing your screen. Okay. I do not see any comments or questions. At least one question I want to raise, because I am not obviously expert in the field of mathematics and geometry, but anyway, usually at least in Lithuania, and I think not only in Lithuania, geometry is like integral part or one of component in mathematics education. We have one school subject, mathematics.
Yes.
And some parts are allocated, let's say, to geometry. What do you think about this, let's say, combination? Because as far as I know or understand, the geometry, for example, mainly oriented to, let's say, spatial thinking, to enlarge, to improve spatial thinking of learners, of people in general. this is very important. Yeah, and quite often geometry is like, let's say, like a small supplement to mathematics, to algebra mathematics. That's all. What do you think?
That's true. That's true. I agree. So if you look at the curriculum, yeah, there is geometry is a small part. I will say is a relatively small part. Even at the university, usually we offer 1 or 2 courses of geometry, including the basic one, axiomatic geometry. And I find this is very essential, especially to pre-service teachers. For high school teachers, I think they should study even more geometry because they need to know a lot of things, and they need to understand other theories so that they can manage, and students sometimes are very curious. Some smart students are very curious, so these teachers should always have the necessary knowledge and the necessary way to orient these high school students. Yes, I agree. Algebra and calculus are more, let's say, more important part of the curriculum, but geometry, the benefit of geometry should be not ignored, especially for special thinking. And this is nowadays, I think, is very important. So for this, I have engineers who are taking this course. Okay. I think because of that special thinking that should be developed for all of them.
Thanks a lot. Oh, we are exactly on time.
Good.
Good. And next presentation, we are moving from your country to another country, back to Europe. Yeah, Czech Republic, Palacký University in Olomouc, and colleague Lukáš, please, it's your time.
Yes, so good afternoon to everybody. I hope that you can see my presentation. Is it the case?
Yes.
Or could you give me please the feedback that the presentation can be seen?
Everything is okay.
Okay,
yes.
Thank you very much. So
yes.
Good afternoon once more. First of all, I would like to thank Vincentas and the organizers for organizing this wonderful symposium. And now I also thank for the possibility to present our small research, which is concerning to scientific reasoning and Lawson classroom test, which was given to our students entering university. All this topic is connected with a bachelor thesis of my student TEREZA, and we would like to prolong it also to master thesis to get some more data and to check some more hypotheses than it was done. Just a small introduction. We are from Central Europe. We have also quite a new faculty building, and now everything is in Blossom Emerald, so it is quite nice. My presentation will consist from 3 traditional parts: some introduction, then a few words about collecting our data, and then presenting the results. The technical details will be given in abstract as well as the references mentioned here in the presentation. So if I will be lucky and somebody will be interested in more details, it will be given in the abstract. Of course, the first question is how to define scientific reasoning. I believe that everybody has some intuitive notion about it, and it is connected with the topic discussed today by Peter or DUŠICA with conceptual understanding and so on. Of course, as we are physicists, so we looked for some definition or framework connected with physics. So this is taken from Leibao website, I-STAR assessment. Probably some of you know that. And that is, I will just cite the second paragraph, that it includes thinking and reasoning skills involved in inquiry, experimentation, evidence evaluation, interference, and argumentation that support the formation and modification of concepts and theories about the natural and social world. So this is the kind of definition what we are talking about. In a general sense, again, we probably might agree together that it might be considered as one of the central goals for the development of today's citizens. And from the point of view of education, the reasoning ability might be an important factor for science learning and for understanding some complex or more complex phenomena and concepts in science education, for instance, energy and force in physics. And it was proved by some researchers. So it's important in education, and for us as instructors to know the level of scientific reasoning of students that are entering our course might be an interesting information, because it might be a kind of identifying of students which might have some difficulties. Of course, I do not want to say that it's some kind of sorting of students, no, but it might be a signal of some warning that some students with low reasoning ability might have problems and maybe tend to drop out from the course and from the education. So that's an important information. Of course, the question is how to measure it. There might be a long discussion. There are several tools. We were quite pragmatic, I must admit, because we tend to use the Larson test in his second variant from 2000. The reason is, as I said, quite pragmatic. It's a paper and pencil style test, so it's relatively easy to organize and relatively easy to then calculate the scores. The concept of the test is based on the questions, on 24 questions, and 22 of them are combined in pairs, in which one question in the pair just is asked about some phenomena, about some experiments, about what will happen. And the second question asks about reason for the answer in the first question. The student gets 2 points in case he answers correctly both the question in the pair. Otherwise, he is not given any point for the total scores. Here is just an example of 2 questions. Of course, I will not read them or I'll try to make you answer because it's too hot, of course, but just to have an idea how it is. So this is the question 11 and the reasoning question 12. By the way, this question 12 was identified as the most difficult question for our students in the whole test. And later I will speak about some categories defined by Larson of scientific reasoning, and these 2 questions are identified for identification and control of variables and probabilistic thinking. I think just recently in Journal of Baltic Science Education there is a wonderful article contribution by Zhu and et al. Which gives account of history, development of Larson test of scientific reasoning. So that might be find many details about the development of this test based on misconceptions, interviews, and so on. Of course, it's convenient that it has been given to several thousands of students, and there are tens of papers dealing about classroom test of Larson test, so we may compare it with other. And of course, it is interesting that it might be given in various phases of education, middle schools, high schools, and also intro colleges, which is the case for us. Now just a few words about the way we got the data. So this is the timeline. We took data in 3 times. It's always in September and October, just in the first 2 or 3 weeks of the semester. So without any university lecturing, just really fresh students entering the university. And the numbers are affected by the fact that I am teaching a course of physics for chemistry students, which makes 61% of all students tested by us. So we started in 2018, then we made some first pre-analysis, then we took the second set of data, then last year we defended the bachelor thesis based on these data sets, and last autumn we again get some more data and we add some more extra option. We ask the students after completion of the test to estimate their results, provide some self-estimation. And then we would like to continue this autumn as well. We were lucky last year because we just managed to get some window with less COVID restrictions, so the students were also present at school and did it in the paper and pencil style. Most chemistry students, how we did it, we altogether we have 446 respondents, and we follow the recommendations provided by a wonderful resource, FISPORT network, provided by the American Association of Physics Teachers. I think yesterday it was mentioned for gains and changes, so it's a really great resource for the teachers of physics. And I must admit that especially because of young men, we need some extra motivation, not just let them randomly mark the answers because it's a multiple choice test. So we offered them some extra points to the overall scores of the whole course because we want them to really make it seriously, not but randomly to take some changes. This is just the screenshot of the FISPORT with the resources concerning two Larson classroom test of scientific reasoning, some recommendations, and so on. And then when we were completed the bachelor thesis, then we made some data analysis by Python and its scientific data libraries. So now something about results. These are the overall scores. I would like to mention that we calculated several characteristics like difficulty index, point biserial coefficients, discrimination coefficients, and so on. And we can confirm that for our sample of students, the Larson test really fulfills the recommended value. So we may say, though there are some researches about some validity consideration, that the Larson test might be still considered as a reliable tool. Of course, we hope that it is not overused because, of course, if we will use it very often, that might be known, and then the results would be not so representing. Our median is just in the middle, 12.7 with median 13. We see that the results are slightly shifted to the lower scores. If we take the reliability index of the whole test and Ferguson delta, the values are very satisfactory for our sample of students. Larson defined or divided the scores into thirds, and which should represent some stages of scientific reasoning, with the lowest concrete operational, then some middle, transitional, and formal operational. These are the results. We can see that approximately 1/4 was in the lowest category and 1/4 in the highest category and 1/2 in the middle. This is not very satisfactory because we come from Faculty of Science, and therefore we could expect that the number of students in the highest category should be higher. This might be confirmed by some other research. For instance, BAO, with a large number of students, over 5,000 in US and China, got an average score 75%. We have just 52%. Also, our colleagues at the Faculty of Mathematics and Physics and Charles University in Prague report that they have nearly 60% of their future teachers of physics in the highest category of formal operational reasoning. For us, there is a clear message that the portion in the lowest category is high, and that might be students that might need some extra support and might have problems in the courses and probably drop out from them. Now, just a quick glance to the difficulty discrimination index and Port-Bissau coefficients. We see that first two questions concerning to the conservation of mass might be taken as too easy. All the other questions are in the recommended interval of difficulty index 0.3 and 0.9. And we see that really the question 12 I was showing before was the most difficult in the whole test. Also, in the article mentioned in the Journal of Baltic Science Education, it is said that it's typical that the reasoning question, the second in the pair, usually gets lower score. And it means that given the reasoning is a more complex task, a higher level of scientific reasoning than just answering the first question about the experiment, about what will happen and so on. On the contrary, if the question given reasoning gets highest score, it means that it's a more probably result of guessing that the developing of scientific reasoning, as described in this article in Journal of Baltic Science Education. Then the discrimination index shows that we have two questions with very high discrimination index, the yellow columns, and they belongs to the proportional thinking and advanced probabilistic thinking categories defined by Lawson. These are the categories defined by Lawson. Again, I will just concentrate on the most interesting parts of them. We saw that really the conservation of mass is very easy, and we might keep it in the test just for motivation probably. But the most difficult parts for our students were correlation thinking and hypothetical deductive reasoning. And this hypothetical deductive reasoning was confirmed by other researchers like Thailand and United States, that really this component is usually found as very difficult, or the most difficult part of the scientific reasoning, of course measured by a Lawson test. Our question was whether there is some correlation between those categories of thinking, and as we see, the Spearman correlation is not very high. It's rather loose. The coefficients are below 1/2. There are some correlations with the total test scores from the categories. These are summarized in this slide. And we see that with the total scores, the highest correlation is with probabilistic thinking, identification and control of variables, and proportional reasoning. And it corresponds with the research, our colleagues from Czech Republic, who find that these categories are probably connected with the ability to use the existing knowledge. So again, these might be important parts of the scientific reasoning. If we saw the box plots for gender, and I must admit that we have some information from our colleagues from Prague that there might be a gender bias in the test scores, we decided to test it. And I think it's clear from the box plot, and it was confirmed by the statistical analysis, Mann-Whitney test and t-test for scores, mean scores, that there is a statistically significant difference between males and females. And this is quite interesting because it is confirmed by our colleagues in Prague. It was confirmed by some researchers in United States and Israel. But on the other hand, there are studies from Thailand and Indonesia who say that there is no statistical significant difference between scores of males and females. So there is a question whether really is some gender bias. Of course, the test was designed by a male. That might be some thing, and maybe this may root in some cultural and historical backgrounds. The other question we asked is whether there is a difference between teachers and non-teachers. It was mentioned in some contribution previous in this symposium, and it's typical in the Czech Republic that usually the students who study teacher programs, typical with two subjects like chemistry, physics, chemistry, math, chemistry, geography, and so on, are considered as students who were for whom it is not the first choice. They probably were not successful when applying for medicine, law, or economy, and now they left for studying science teachers. So it was our question whether really there is a difference in the level of scientific reasoning for the students entering the university. And I must say that for me it's a pleasure to say that not. For our sample of students, there is no statistically significant difference in the level of scientific reasoning between students in non-teaching programs and programs for prospective teachers. On the other hand, as it was mentioned, the overall scores is not very high, so that might be some fact that may affect this result. As I said last year, we also try to ask students for their estimate for the results in the test. The mean was slightly below the real score, so the students in average slightly underestimated their result, but there was no statistical difference between male, female, or teachers and no teachers. So I'm running out of time, so there's a time for some conclusion. So just to repeat, we might confirm that Larson test is a reliable tool. We can identify as some important parts of scientific reasoning, like hypothetical deductive reasoning, probabilistic thinking. And I think it's in agreement with other sources that the training in scientific reasoning may have a longer-term impact, and that just teaching physics and so on doesn't usually make a great shift in the scientific reasoning, of course, again, scored by the Larson test of scientific reasoning. So what may be promising is that there is some study from, I think, again, Indonesia, that in biology, the 5E learning model was recorded as making some good shift in the scientific reasoning abilities, again measured by this Larson test. Our future plans are make some eye tracking for selected Larson test problems and exploring the dropping out from the lowest category of scientific reasoning students. I would like to thank to our colleague Irena Dvořáková from Prague to turning our attention to the topics and providing us some extra materials and sharing data. And the last take-home message is, please let us try to support also the scientific reasoning. Thanks for your attention. I hope I managed to use the time properly.
Oh yeah, small shift. Never mind. Thanks, Lucas, but sorry, I do not see any questions, and we have no time for questions. Obviously, it was interesting, and I think it will be possible to analyze later on. Let's move again from Europe to another part of the world. Do we have a colleague from India?
Hello, am I audible?
Yeah, hello.
Hey, am I audible?
Yes, you can start. It's your time now.
Yeah. Just now I have shared my screen. Is it visible to you?
Not yet, but we are waiting.
Okay. Let me try once again.
We see you, but
Yeah. Desktop. Okay. Now is it visible? My screen is visible?
oh, now it's okay. Full mode, full view.
Is it okay?
It's okay.
Okay. Thank you. Thank you, Professor, and the organizer of this 4th International Baltic Symposium on Science and Technology Education. It's my pleasure and honor to participate in this fourth Baltic STE 2021. Myself is my name is Narendra, and I am working at Homi Bhabha Center for Science Education, Mumbai. My title of today's presentation is the effective use of technology in classroom for implementing remedial module to overcome school student misconception. In this presentation, I will discuss about difficulties in life processes, use of technology to overcome this misconception, RIHU related material, research, and then methodology and conclusion. As we all are aware that this Novak statement, the role of conception in constructing human knowledge has been enhanced in science education, and considering the importance of the student conceptions, the process of student conceptions, a lot of research is going on, and within 2 days, yesterday and today also, many presentations highlighted this issue, the importance of conceptual understanding or sense making. Many researchers focus on student conceptual development and cognitive process. This process is very important because the connection among concept is one of the primary distinction between expert and novices, and that's why we see a lot of studies related with this issues, and students have a lot of ideas, especially in science, that lead many theories or alternative conception or misconception, and we in this constructivist approach, we are aware that the students are not tabula rasa, they are not blank slate, they come with various new ideas, and this is a little bit about our understanding. Concept is nothing but it's a scientific idea underlying a class or things or event, and the process conception is an individual idea of the meaning of a concept. And when we use a misconception, that means any concept that differ from the commonly accepted scientific understanding of the term. This misconception study basically, or you can say this problem is not only related with the children, but it's also common in adult, and many terminology we can see in this context. And the movement actually the Rosalind Driver and her colleague in 1980s initiated these studies on student misconception, alternative conceptions, or prior knowledge. And we have a database from students and teachers conception and science education, that's STCAC by DeWitt. And here we can see the analysis which showing the physics because many studies are conducted during that time, since 80 to 2000, we can say 2009. Most of the studies related on misconception are from physics area, then chemistry, and then biology. Today actually I am presenting a small component from my study that I conducted during 2013. That study was basically related with the student misconception and development of remedial materials. That was my study's title. And we generally assume that school level students may have misconception in biology. The possible sources of misconception may be students' previous knowledge, teachers' knowledge, teaching method, textbook, and other material. And the intervention program, which is research based, may overcome or may help to remediate student misconception. In this study, I divided 3 parts. Basically, the study divided in 3 parts. The first part was the identification of misconception, and then second part was the design and development of remedial material, and third was evaluation of remedial material, where I use the technology. That part basically I am sharing today with you. In the first part, identification part, the focus was basically on student knowledge and teacher knowledge, and also the source that students are using textbook at the school level. So I analyzed the textbook. That's for identification of the misconception, and then I developed conceptual concept-based objective tests, CBOTs, which I use to assess the impact of my remedial material. This is overview of the study. Basically, as I said, this is just a flow chart, you can see. Now, for the identification phase, that's the phase 1. More than I think 969 students participated in that open-ended questionnaire, and similarly, I also conducted data from 110 teachers. And in a third phase, that's where the remedial material, whatever the remedial material I use, there you can see different for different module, number of participants are a little bit different, because this phase was an experimental phase, and the first phase was a descriptive survey. So in this study, I use a mixed method, and as I said, here I will only focus on technology part, because the technology not only used for teaching, but also in some cases the technology used for student misconception. The study conducted by Squares, they used BioView for identifying the school student misconception about photosynthesis, and then the AD tools developed by Garvin and Doxas, and I think that tools now also many researchers are used to identify student misconception. Stein also explored the online instrument, and they used for different science concept. The instructional media for effective teaching and learning, as I said, apart from identification, the technology also used for effective teaching and learning, and I think we will get a more research literature on this area because of the availability of technology and the development in technology, and from Web 1 to Web 2.0 versions, a lot of use of technology we can see in our instructional in our instructions. These are some studies where Vetterman viewed multimedia as a source, where he studied the impact of graphics, video, animations, image, and sound to textual information. Similarly, the Millard study show that interactive technology will support learning, will not take place if technologies are used in traditional ways. That means we have to decide how to use, how to implement the technology, not just using for the sake of our teaching learning. How to use the technology. That's why that Scholar and Mishra's pedagogical TPAC, techno-pedagogical content knowledge model, that is very useful. And when we have to understand when we are using any technological online or any digital learning mode. The Johnson argued that the drill and practice technology has turned out to be largely ineffective, and that simulation technology based on constructive learning principle provide measurable learning advantages. So here one point is very important as a science and math teacher, educator, or as a researcher, that this technology is there, animations are there, simulations are there, different apps are there nowadays. So to what extent we are providing the scope to our learner, that is also important. Otherwise it will not constructive learning if we are just demonstrating or just showing there or just
It seems that something with internet connection.
Hello, am I audible?
Yeah, you returned back.
Yeah, sorry, here power cut, because of that power cut, the internet connection was disconnected. Now I am using my mobile cell phone connection. I hope that I am audible to you.
Okay, you can continue.
Yeah. Like yesterday, you face a problem of electricity at your place, no? Similarly, just now I face the same problem here.
We have 3 minutes. We have 3 minutes.
Yeah. Just now I'm concluding. I hope that my slide, my transparency is visible to you. Hello?
Yes.
Is it visible to you?
Yeah, it's visible.
Okay. The point. I was discussing about the use of technology, and similarly for the remediation of misconception and remedial program, various researchers use the technology, like here in the case of Kinner, who use technology to remediate misconception in genetics for 12th grade student, and he CS computer simulation use. Similarly, Nicklin also use technology for physiological experiment for demonstrations. Then Ma said this program is very famous, just in time teaching, which used to remediate misconceptions. And Sepnis investigated the effect of computer-assisted instructional material, CAI, related to photosynthesis topic. Actually, CAI is a very common during 90s and 80s period. As I said, this remedial material basically I use in the form of whatever the module I developed on respiration and photosynthesis, transport of material, nutrition and growth, and reproduction. And here the purpose of this remedial material is basically create awareness of the misconception held by the student, and to create a forum to confront their misconception, and so it will be help to repair their faulty mental model and reconstruct it appropriately. That was the purpose, and the technology that I mentioned, I used basically for the transfer of this remedial module, where I use the PowerPoint presentation, lab activities, worksheet, and follow-up discussion. In this context, in biological sciences, many abstract concepts are there. So some animations, some simulations, I found they were very useful for the students to understand certain concept. The concept of photosynthesis particularly. The concept of photosynthesis is very difficult for the student, like the function of heart or structure of heart. So in this life processes, lot of misconceptions students have at school level, and to remediate this misconception, if we use some sort of technology, some sort of both, not only technology, both blend, I think online and offline, or some activity based teaching, some demonstration, all sort of activities is needed, but particularly to show them some certain abstract concept, how heart work, how the process of photosynthesis take place, how plant absorb water, and how the process of transpiration take place. So these are certain abstract concept, and for the explanation or for the better understanding, the use of technology, I found it's very useful. It's not only facilitate classroom learning teaching process, but it also useful to create curiosity, interest, and gel among the learner. And as I said, it's a need of designing and development of open educational resources, or e-content, or online material, module packages, or instructional material. And most important thing is we need a data of student misconception, because yesterday also somebody mentioned, and now today also in the afternoon session, that for a pre-teacher education, we need such a data, so teacher can understand, the future teacher can understand that what are the student misconception and how to deal with these things. Simulation learning environment are having profound impact. These are the research found, and lot of particularly when we say the remedial material, if we use correcting wrong notions or ideas of student, providing fine structure with concept and subconcept, relating one things to other, concept and subconcept interrelation with each other. If we covered all these modules in our instructional material or intervention program, and then we can use either technology or either face-to-face mode, which help to overcome the student misconception. For many intricate, abstract, and scientific concept and principles in biology, experiment activities, use of technologies, multimedia, internet play a vital role in the process of learning science. Thank you very much for giving me the opportunity.
Thanks a lot. It was also interesting, and after symposium, we will discuss about presentations. Maybe it will be possible to collect all of them and to share on our website. We will discuss with everyone. And again, from India, we're moving to Czech Republic again. And I think we have colleagues MARKÉTA and Dana from Charles University.
Hello.
Yeah, okay. Please go on.
So, hello, my name is MARKÉTA BARTOњOVÁ and my supervisor is docent Dana KRIČFALUŠI. I'm currently studying my doctoral studies at Charles University, Faculty of Science, Department of Teaching and Didactics of Chemistry. And I'm interested in integrated teaching, and today I would like to talk about worksheets for integrated science. First, I would like to talk about what integrated teaching and integrated science is, or how I see it. So in my point of view, integrated teaching connects content, expected outcomes from framework educational program, which is our national education program, from all subjects that are interconnected. It also connects aims and key competencies from the framework educational program. What is very important is that at the same time, a new aim is formed, which results from the integrated whole. It also implements interdisciplinary relationships and connections between theoretical and practical activities. Integrated science then connects knowledge from chemistry, biology, physics, geography, and geology. And students think about topics from different point of view as a chemist, biologist, physics, geographist, and geologist. It should be as close to the real life as possible, and students should verify their theoretical knowledge in practice. Here in the Czech Republic, we teach each subject separately, but our framework educational program enables us to make integrated subjects that would connect contents from subjects that the school choose. So it is possible to have integrated subject that would connect all of these subjects, but it is not common at all here in the Czech Republic. Worksheets are defined in different ways as well. One point of view is that is it just a set of tasks, exercise, didactic image material? Another point of view it is a piece of paper with questions and exercises for students. Another point of view is aimed into the purpose of a worksheet, and the purpose is to repeat, consolidate certain knowledge, skills, and creating habits. We can see a worksheet also as something that should minimize the role of teachers and, on the other hand, give the students main responsibility in their own learning. Also, a point of view that it is a piece of paper that contains problems. And of course, worksheet can be all of this. Worksheets for integrated science must respect activating learning methods, as well as active learning, and it should include different types of tasks. And for integrated science, the worksheet must contain such tasks in which there is a practical use of intersubject relations and context. Each task must connect to at least one expected outcome from all subjects in the education area meant and nature from the framework educational program, and the subjects are like I already mentioned, chemistry, biology, physics, geology, and geography. Now I would like to talk about methodology, about how to create a worksheet for integrated science. It is important because, according to our research, one of the main reasons for not implementing integrated teaching into lessons is a lack of suitable didactic materials, according to our respondents that were teachers from grammar schools. So we thought about how to overcome this obstacle, and we tried to create suitable material that will meet the needs of teachers as well as students. We put it together a methodology that we call CCCTER, which stands for Choose, Connect, Create, Try, Evaluate, and Remake. What choose means? Choose means that we should choose one main topic that can be from chemistry, physics, biology, or common life. We have chosen a topic from chemistry, halogens, and then we talk about how to teach this topic in an integrated way. A suitable way of doing that is by making a mind map or a concept map. And the terms is based on our experience, knowledge, but also on literature, for example, textbooks from biology, chemistry, and physics. Then we divided our main topic, halogens, into 5 subtopics, which are plastics, ozone layer, chlorine cycle, halogens in our hands, and look for structure behind everything. And we use this map in the next step. The next step is to connect. We have chosen an expected outcomes from all subjects of educational area, man and nature, as well as cross-curricular subject, environmental education, that could be connected to the subtopics. So this is the first connection, the topic or subtopics with the expected outcomes. The other connection is that we try to connect theory with practice. An example how to do that is, for example, task. Here in the Czech Republic, we have a well-known disinfectant called Savo that kills bacteria, viruses, algae, and lower fungi. And students have this information or get this information from the label. And their task is to verify the information by experiment. The student gets simple instruction how to make a nutrimedium from home ingredients, so they can provide this experiment at home as well as at school. And then they should verify, is it true, and see on their own eyes. How to connect the topic or subtopic with the expected outcomes is shown here. So, for example, an expected outcome from physics is that the pupil shall distinguish between scalar and vector quantities and employ them while solving physical problems and exercises. And an expected outcome from chemistry is, for example, that the pupil shall characterize the basic groups of organic compounds and their significant representatives, evaluate their raw material sources, their application in practice, and their effect on the environment. So in the third step, this is create, and we took these 2 expected outcomes from physics and from chemistry, and we transform this theory into practice, into the task. The create process transforms the theory into practice and also connects theory and practice, and it's a creative process, which is one of the advantages of making a worksheet that it develops teachers' creativity. And this task in particular connects physics, chemistry, and math, and further on, for example, environmental education. And it is an example how a task can be made, and it's based on the framework education program and connects theory with practice and several subjects from the area man and nature. And also it's connected with our everyday life. Then we have the worksheets that is ready, and we need to try them in class with a sample of students and get feedbacks from students. The other step is to give the worksheets to experienced teachers for evaluation and get feedback. For example, it can be provided by an interview. Then, according to the feedback that we got, we remade the worksheets to be more suitable for students and for teachers as well. And of course, these three steps can be repeated as many times as needed. And all of that is done. We have suitable worksheet for integrated science that is suitable for teachers as well as for students. So thank you very much for your attention. Here is my contact in case that you need it. And if you have experience with integrated science, teaching and materials, I'll be more than happy to learn from you. Thank you.
Thanks a lot. Colleagues, questions, please. We have 5 minutes till the coffee break, and it would be good to give some questions to our colleagues. My question, for example, Lucas, okay, please.
So thank you. I'm sorry if I have missed that. Maybe it was said, but I'm interested in what age of the students are your material designed for? What level?
Yeah, thank you. I didn't mention it. It's for grammar school students. The best age is about 16 to 17 years old students, about that age.
Mm-hmm. And so you suppose, because at this level of secondary school, the concepts are more complex than, for instance, for the basic school or elementary education. So you think it's still possible to develop it in the desired depths, on both the concept on physics side or chemistry side, or do you have experience from that?
Mm-hmm. I think it is possible because they gain the basic knowledge in elementary school, and I have experience with that because I have like integrated subjects that is once a month for selected students, and they go into that in their free time and they do very well.
Okay, thank you.
Thank you.
Hello, can I ask questions?
Yeah, Narendra, please.
Yeah, thank you for your wonderful presentation. Just I would like to share that here in India also we have one longitudinal project. The project name is basically Participatory Action Research Program. We are doing with one school which is nearby our institute, where we started from grade 3 to now we reach up to grade 8. And where we use the worksheet, and that worksheet designing, slowly we learn what type of activities should be there in worksheet, or what type of assessment question should be there, or where the worksheet will engage the student. So all 3-4 criteria we are trying to study when we are designing worksheet. So your presentation is very useful for us, I think so. I just would like to know that I don't know what the problem we are facing here in India after because it's a participatory and we are covering the entire syllabus of that grade. For example, if we are this year we are focusing on grade 9. So entire 9th class science syllabus we have to cover, and on each topic, whatever the chapters they have, we are designing worksheet on that. And after collecting that data, it's very difficult to analyze because such a huge data we are getting. Because in India, we have a crowded classroom, more than 60-70 students in one class. So my question is that how to deal with this such a data, because it's found difficult for us. Any comments on?
I didn't get the question. What is the core of the question?
My question is that we developed a worksheet in our longitudinal study, and we gathered or we collected a lot of data. And the question is how to analyze that worksheet, whatever we collected. Just for very specific questions regarding this worksheet. In your case, what was your focus after collecting the worksheet? How you are looking that worksheet?
Yeah, well, I'm not analyzing the worksheets. I'm getting feedback to make the worksheets suitable for teachers and students, and so they can be used in different schools. But if I would analyze that, I would focus, for example, if they get better in math solving problems or critical thinking on. And one time I thought about making the research about concept mapping. If they get better in concept mapping, that was based on the integrated teaching, that integrated lesson. If they get better in concept mapping through the integrated teaching lessons. I'm sorry, okay, I think my answer was not satisfying. Thank you.
Thanks a lot. It will be possible to continue all discussions after symposium or to organize post-symposium individuals or sessions or so on. No problem. Life continues. Okay, and colleagues, thanks for this, for your work for this first part of our second session. And now we will have 20 minutes coffee break according to our program, and we will continue at 3:20. Okay, dear colleagues, I hope all are okay after coffee break, and let's continue our work. We have 2 minutes earlier, but we can start in order to have more time for presentation. And next, let's move from Czech Republic to our neighbor, to University of Latvia, and colleagues Rita and DAGNIJA will present something for us. Okay, please continue.
Hello, everybody? Do you see my presentation?
Hello, Rita.
Okay.
Yes, it's okay.
Yeah.
Yes, okay, we see it.
Yeah. Okay. I would like to present about students' readiness for MOOCs in Latvia. But before I am speaking about this, I have a question to all participants. Do you know where is situated Latvia? I think you know where is situated Lithuania, but Latvia also is a small country and with less than 2 million population and is situated between Lithuania and Estonia. Why I would like to speak about MOOCs, because MOOCs is topical during COVID pandemic. The main keyword characteristic MOOCs during COVID pandemic will be growing, remembering the MOOCs, and of course, MOOCs now is fundamental need of modern civilization. Instead, attending physical classes in the traditional institute of learning. Why MOOCs is important in higher education? There are 5 ways to how MOOCs could affect teaching and learning, because I think the main problem is changing the nature of credit points in academic studies. Of course, it is materials for design, development, delivery, supporting for learning, developing blended learning, and of course, here is creating learning communities. What mean readiness for learning MOOCs? What do students need to know before taking these courses? Of course, they need self-directed studies, self-efficacy, motivation, communication, and of course, technological skills, computer skills, internet skills, and access to ICT facilities. Aim of study was to find out what students' understanding of online learning was and to what extent they were prepared for MOOCs. The research question was raised. There is a relationship among technical skills, social communication skills, self-efficacy, self-directness, and MOOCs readiness. Study design. This study have been carried out before COVID pandemic, and it is in year 2017, and this study took together with Malaysian Open University, and they developed questionnaire, and you can see that here is 4 independent variables: social communication competencies, technical competencies, self-directness, and self-efficacy, and 1 dependent variable: how students are ready for MOOCs. Sample, of course, studies was developed in Malaysia separately and in Latvia too. We had students from different Latvian universities, and the most part of students belong to bachelor level program, 53%. But a very interesting fact is that only 9% of students have enrolled in MOOCs. Data processing will make descriptive statistic, factor analysis, Spearman correlation to clarify correlation between factors, Cranbach's alpha, Mann-Whitney U-tests, compare opinion full-time and part-time students, and Kruskal-Wallis test. What are results of our studies? Finding one is very interesting, that students are most motivated for enrolling in MOOCs by the possibility to widen knowledge, socializing, personal interests, also for networking, and of course for gaining credit of university course and continue of professional development. Finding two, if we speak about differences between full-time and part-time students, that you can see that there are statistical significant distances between in communication, because it is a possibility to meet many new peoples, and also self-efficiency, that students are agree that they are confident to study in this online course, and also self-directed manage studies according to study plan. If we see about responses distribution depending on the responses age, you can see that students age from 26 to 45 are greater life experience, and they are able to assess better the MOOC's possibilities than younger and older students. In this study, we identify three main factors. Factor 1, MOOC's readiness. Factor 2, self-directness and social communication, and factor 3, self-efficiency. You can see that there is a correlation between factor 1 and factor 3, and weakest correlation between factor 1 to factor 2. If we speak about MOOC readiness, that this factor describes the student's readiness to engage in MOOCs, and you can see the student interest is in accreditation in university, and how this MOOC course contributes to what degree. Of course, how it is interesting for conventional course, and they are ready to involve in this process. Finding 5, self-directness and social communication is the biggest factor with more items, and students access they choose to learn in self-directed way, determine own learning goals, and of course work intensively. And if we speak about communication, that you can see that they need communication and socialization with course mate, teacher, and forming constructive dialogue. Finding 6, self-efficacy, it demonstrates students' confidence in oneself. And MOOC, of course, it is the new challenge for all students, and they think that learning online is highly engaging and interesting, and believes that anyone can learn in online environment. The main conclusion, the results showed that students' understanding about MOOC's readiness differs a bit different from the diversion blocks of the model used in the methodology. According to Latvian students' understanding, the MOOC's readiness is mainly connected with self-directness, social communication, competencies, and self-efficiency. Interesting that technological competencies are considered as transversal skills and do not create problems in using the MOOCs. Students with certain life experience value higher the possibilities given by MOOCs. Of course, it is normally, and in general, it can be considered that MOOCs are a challenge and students are ready to accept, but no problems is in credit points. And student self-directed learning process has essential importance for enrolling in MOOCs. And however, if they have to make a choose between face-to-face learning and online learning, they give preference to the face-to-face study. Publicity of the study about MOOCs, you can see our papers published in several issues, and thank you for attention, and I wish you merry midsummer celebration. Latvians from tomorrow has 5 free days for midsummer celebration, and what do we doing in this celebration? We eat Jāņu cheese, several cheese with special cheese, and we drink beer, and we pin ristles, and we light bonfires. Thank you for attention. Your questions?
Thanks, Rita. It was really fine. Please stop sharing.
No questions?
Please stop sharing your screen. Please stop sharing your screen. Rita, do you hear me? Oh, okay. It stopped.
Yes.
Please stop sharing. Thanks for your presentation. It's really nice. And I just want to add that the same approach in Lithuania for celebration of this Midsummer Day. Yeah, we can, of course, discuss as much as possible in which country, in Latvia or in Lithuania, is the strongest celebration. But I think it would not be possible to finish with such a discussion. In both countries, this celebration is really strong and smart, and it's really nice. Yeah, and just to say that people who wants to experience this event, you are welcome next year, obviously, to Latvia or to Lithuania, and to take part in our, we called name in Lithuania is Jonines, in Latvia is Lygo, right?
Yes.
Well, and it's really traditional event and very rich with traditions, etc., etc. It's really interesting. One question, because we have some minutes left. It's really interesting about this massive open online courses. And obviously it's connected with technologies, with some online teaching and learning. But during pandemic time, I think that learners in general, students, learners, and also teachers, lecturers experienced, let's say, not some real challenges, some extreme situations, etc., etc. And as you mentioned, generally, let's say, people prefer face-to-face process, teaching and learning. And for example, at least in Lithuania, it's very, very deep discussion. Teachers are unhappy with remote distance teaching, the same with students, and currently, for example, at least our students, secondary schools and gymnasium students, they are step by step returning back to schools, despite that academic year is approaching to the end, and they are very happy to be again face-to-face, let's say face-to-face mode of education. What do you think?
Yes, I am agree that face-to-face is not is the best way to learn, and of course I think that we choosing from MOOCs the course preparation of course materials and some methods for teaching, learning, some quizzes and etc. But of course I agree that face-to-face is the biggest learning.
Yeah, obviously it's not. It would not be correct, for example, to compare or to keep as equal possibilities. Obviously not. Technologies are good, and different systems like MOOCs, for example, massive open online courses. It's possible to access different people around the world, and to gain some knowledges, to learn new skills, etc. It's obvious, but I'm speaking about this emergency mode distance education. What happened during pandemic time? It's not the same. I want to emphasize, it's not the same mode. Let's say distance education mode or remote education mode as we understand, but so-called emergency remote education mode forced by pandemic situation. And this is, let's say, both modes are really different, despite some similarities, but they are different, and it's with different challenges.
Yes, I think that we have a good school for teaching learning in remote learning environment during this COVID pandemic situation, and I think that we have a good idea what from this learning we need to to explore a future, because there is also some good things in this remote learning, and some methods application I see we will use in future in face-to-face learning.
Okay, thanks, Rita. Do you have some more questions or not? I see no more comments. Yeah, no comments, no raised hands. Everything is clear. Thanks once again. Laidzīvo Latvia. Just not to consume a lot of beer, because it's somehow dangerous. Yeah. Do we have next presenter from Moldova, Mikhail?
Yes, good afternoon.
Oh, okay. It's really nice to see you. Moldova.
Hi.
Please introduce yourself and you can start.
Yes. First of all, let me share my screen. Tell me if you see my screen.
Yes, we see.
Yes.
At least I see. I hope colleagues also see very well.
Mm-hmm. So, good afternoon once again. First, I thank Professor Lamanauskas and organizing committee for acceptance and interest in my communication. I have to say that I have beautiful memories about CHBILI. In '89, as a student, I have participated in physics Olympiad among students from pedagogical universities from former USSR. Now I teach theoretical physics at Tiraspol State University. It has a pedagogical profile and is located in Chisinau, capital city of Moldova. Today I will present a didactic approach named Learning by Being. Learning by Being is based on 3 pillars: learning effort, metacognition, and student-teacher feedback. Shortly, on students' ownership on cognitive goals and their deep intrinsic motivation. In this communication, I will analyze several moments. First, the evolution of educational paradigms from learning by doing to learning by being. Second, the correlation between learning effort and metacognition. Third, student-teacher multilateral feedback and correlation between learning by being and inquiry-based science education. And finally, some conclusions. Achilles heel of today's school is low student motivation and interest for learning effort. So the school is powerless against widespread populism and has various aspects from learning by doing, so-called student-centered education, So low motivation is determined by a series of factors. First, discrepancy between what adults see as relevant and useful and how students look at the things. Born in the digital age, they realize that today knowledge will become outdated and useless, just as many professions or even entire domains of today's occupation were unthinkable several decades ago. Second, often students only repeat the teacher's precise instructions. Such research in commerce excludes wondering, satisfaction, or curiosity, question. So it's about the absence of intellectual challenge. And third, today ludic character of education is in trend. Lessons should be fun, like the school belongs to entertainment industry. But for students, digital gadgets are fun. So digital environment of education is mandatory. If we want not only remove boredom, but also achieve some academic success of students, the solution is to increase the students' independence degree in learning. This independence in learning should go until we will reach the students' ownership on learning goals. Our didactic goals should become their learning objectives. This corresponds to visible teaching and learning. Second, in order to obtain the assumption by the students of cognitive goals, the communication within the lesson should be based on mutual student-teacher feedback. And third, students' empowerment through metacognition. In such a way, modern didactic strategy contains three pillars: learning effort, student-teacher communication, and metacognition. The first step in the ladder of educational paradigms is learning by doing. For example, a form of learning by doing is ludic education. According to the theory of visible teaching and learning, ludic education has an impact factor on academic achievement on students equal to 35%, compared with the benchmark level, which is equal to 40%, when an experienced teacher applies permanently the same conventional technology during 2 academic years. Learning by doing has a negative impact factor. These numbers demonstrate once again that education isn't entertainment, and conventional teaching remains a solid option in modern times. The second step after learning by being is learning by understanding. A well-known example of learning by understanding is inquiry-based science education. According to visible teaching and learning, it has an impact factor of 77%, twice higher than learning by doing. So the complexity degree of communication in classroom makes the difference between learning by doing and learning by understanding. So communication should be seen as leverage for enhancing students' involvement in classroom activities. The third step after learning by understanding is learning by being, when the students not only understand but also assume the learning objectives. And learning by being, so students are the subjects of their learning process, construct their cognitive path. Learning by being is about the students' ownership on cognitive goals. Here I will present several features of learning by being. For example, first, the ability of students to carry out independent research, in other words, guided self-scaffolding. Second, knowledge of success criteria, or even more, assumption of success, which is the driving mechanism in learning. In order to achieve this level, students should be accustomed with inquiry-based science education projects. Years of permanent daily implementation in classroom of inquiry projects will bring an added value in this term. And third, the ability of students for revealing similarities and patterns, which has an impact factor equal to 132%. It is the ability to connect the new information with the previous knowledge from the category that is not forgotten. So this approach relates to the formation of analytical and critical thinking skills, which are the basis for lifelong learning skills. In this way, learning by being, it is about high independence degree in learning. In other words, teaching should be seen as coaching in sport, when the athlete not only knows what the coach wants from him, but also assumes this task as own goal and has all physical, technical, tactical, emotional means for achieving the goal set initially by the teacher or trainer. Learning effort and metacognition. The main goal of contemporary education is scientific understanding of the world by the majority of population. Widespread negationism and low vaccination rates brilliantly demonstrate how school succeeds in this area, informing scientific understanding, which remains for many educational systems fata morgana in education. Shortly, scientific understanding of the world means understanding the phenomena of nature, and understanding technologies, understanding the events in society, and familiarity with scientific research methods. The cause for low scientific understanding is low learning effort or the search for royal ways in science. Learning through intellectual effort is a well-known didactic principle which reflects that ascension is only uphill. It suits to Vygotsky concept of zone of proximal development. Namely, because of this, ludic education has a negative impact factor. Intrinsic intellectual effort in the atmosphere of empathy in classroom that encourages verbalization and fosters communication. We should speak about education centered on students' learning effort rather than education centered on student. Also, some pilot studies suggest that teaching programs based on the 5-year approach increase motivation and remove boredom by creating positive impression to the learners. Indeed, motivation and students' interest have to be seen as the first bricks in the foundation of any learning by being approach, when students' ownership on cognitive goals is targeted. Student-teacher mutual feedback. So two-way communication channel is mandatory component of any constructivist didactic strategy. Teaching and learning shouldn't be with closed eyes. When the teacher doesn't know how the students received his message, and students don't know also and don't understand what actually are the didactic objectives of the lesson. From the results of visual teaching and learning, I have selected some factors directly related to feedback. Here you see these factors, but I have to say that the last two strategies, student-centered teaching and problem-based learning, they are below the benchmark level of 40%. I mentioned it because in the case of student-centered teaching, we have a student as the passive passive object of teacher's action, and B, because the majority of teachers don't apply permanently problem-based learning in their classes. Further, I will present some steps to be followed by the teacher in classroom in order to achieve students' ownership on the cognitive objectives. In other words, how to put into practice learning by being concept in the frame of an inquiry-based project carried out by students. So related to teacher, I will underline several moments. First of all, formation of student ideas. So-called the first question. The general solution is to A, ask open question and give positive feedback to let students realize the necessity for the revision or development of their initial ideas. Second, supporting or guidance of students' research developed in groups. And third, facilitation of analysis and drawing of conclusions. So here the teacher asks the students to formulate as concisely as possible their conclusion. B, the teacher asks the students to check if this conclusion formulated by them corresponds to the results of measurement, and the teacher encourages students to reflect on what they have done and what conclusion they have reached. Related to students' actions, I underline 3 steps. First, based on their previous ideas, students formulate and explain their hypotheses. Students participate in planning the experience by discussing the details. I have to say that students do not create the research plan, but at least they understand and accept it. Here, in fact, we are talking about assuming the objectives of learning. Second, research. As a group research, as a group work. Students here collaborate and share tasks being in the same group. Avoid as much as possible individual work, and the students report the results of their group work in front of the whole class. So again, it is about enhanced degree of communication and verbalization of new learned terms and notions. And third, recording and analysis of measurement of research results. Of course, the results should be transformed into a table, but I would like to say that informal notes should be considered appropriate for each student. Although informal in their content, this note should be mandatory for each student, because such an inquiry-based task contributes to the formation of lifelong learning skills. And finally, some conclusions. First, active learning or doing is not yet understanding, and its impact factor could be lower than conventional teaching. Moreover, apparent understanding shown in usual summative tests isn't equivalent to the formation of lifelong learning skills, or to the formation of that knowledge that is not forgotten. Second, scientific understanding should be based on learning effort and on ownership of learning goals. More simply, for students, the desire and effort for knowledge should come intrinsically. So it is the core idea for learning by being concept. And third, learning by being is based on metacognition, It means that students not only understand what they do, but understand their way of thinking. And for mandatory student-teacher mutual feedback, I have to say that a relation student-teacher should be interpreted as a harmonic oscillator. And fifth point, the synergy of all mentioned factors would bring added value in terms of learning by being approach. And I hope I haven't exceeded my allotted time. I don't see the clock.
Thanks a lot. You are really finished on time. Colleagues, questions, please. And stop sharing maybe your screen.
Mm-hmm.
And it is really interesting, and
but it was in a telegraphic way.
Yeah, because it's also somehow in scope of my interests related to scientific research, so-called scientific research activity of students and also teachers. And can you shortly explain about the situation in your country? Because at least I have not enough, let's say, information how it's going on in Moldova right now. For example, let's say related to teachers, how teachers are prepared to work in this way, to perform research activity, to involve students in research activity.
We have a good national-wide project, the classroom of the future, if translate properly, classroom of the future, and they support nationwide research projects of the students via digital technologies. Also, they support physics laboratories, new physics laboratories. All of this through project-based learning. I think this is good news. Also, I could say about inquiry-based science education. In 2007, 2010, it was a FIPE7 project, Fibonacci project, which involved many European countries, and they developed supporting materials for teachers in order to let them know, to customize them with the idea of inquiry in classroom. The inquiry in classroom is hard to develop for an unexperienced teacher. That's why I think that conventional teaching will remain a solid option. We have to say honestly, all of us have been formed in a conventional teaching, isn't it?
Yeah, this is intergenerational, let's say, issue.
But once again, I will put in the middle of any didactic strategy the learning effort of the student. So let's say if we discuss about MOOC courses, in these MOOC courses, for example, should come students with already formed attitude. So physics lesson, it's about forming skills, forming attitude. I like it in this sense very much, the presentation of Professor Demkanin. In one moment he said about how self-transcendent principle, which I think it is correlated with personal learning effort.
Thanks, Mikhail, for your presentation. And okay, we should start with next presentation. I see that our colleague from Finland is ready. Antti, please.
Antti, well, this is Kalle, actually.
Okay, okay, no problem.
You hear my voice, okay?
Yes.
And now you see my presentation, I hope.
Okay, it's okay.
Okay, good. So I'm going to show this quite simple comparison of two methodological courses from Defense University. Perhaps the most interesting thing here is that actually during the whole COVID-19 disaster, what has been going on, our review by students have been very positive. I mean, really positive from this distance teaching. And I can also contribute another research which compared students' attitude towards distance learning over traditional learning, and it seemed from this another research, which had like something like thousands of students participated to that, was that students' attitude had changed, so that during this COVID-19, before they were very negative against distance learning, but now they have become very positive. So I think what I saw from previous presentations, the main problem was that students had been given option perhaps to be in distance or to continue the traditional way. But if you don't give them, like I work for military, we don't give any options. Either it's distance or it's traditional, and we had been completely distant for over a year now. At least in this kind of academic teachings. Of course, you have to, when you have to go to forest, you have to go to forest. That's a different thing, or any other real environment. Anyway, this is the guy who was just mentioned, Antti. I saw Antti is online too already, and Antti has actually mainly written this paper what was sent, so that I tried to do my share by at least giving this presentation here. I will, and this is me. So as you see, we have both been quite long in Defense University. Don't ask me why. I don't know. Okay. Content of this presentation is, first I give some kind of introduction, and then there are some I show how we understand student-centered learning, action research, flipped learning, and and perhaps how they work in distance education. And we have two courses, methodology courses, which are sort of combined. Methodology course 1 should be supportive to methodology course 2. We have even methodology course 3, which we haven't haven't been established yet. At least we have content for that. And then we compare students' feedbacks and make some conclusions and remarks. So okay, and why do we need to teach mathematical, or not? Sorry, not mathematical. I'm a mathematician myself. It's not all mathematical. It's normal research methodology. Normal research methodology, but of course a lot of it is about mathematics, since already in first course it's, I would estimate, more than half is statistics, and then this course 2, its content is that kind of areas where, like decision making theory and Markov chains, Monte Carlo chain theory, things what our students can use in their graduate works. Okay, our curriculum changed just 2020, just before this COVID thing started, and anyway, this first research methodology course we mainly did through traditional ways, but before this methodology course 2 started, it went to complete lockdown. So it means that everything had to be in distance. I think that was actually positive for this how we managed this course, because everything from the beginning to end was distance education, and there was no option, and everyone had to just accept it, that we can't socialize face to face no matter how much we want. And it might have affected the students' review too, like I believe. Anyway, first course gives basic knowledge and all sort of things, mainly statistics, and of course how thesis should look like. Very little about ethics, because we in military we mainly agree that it's not our thing, ethics, except sometimes when we have philosophical discussions, of course. Now, second one gives actual tools for the research, which is also one thing, and it gives exactly tools for that research what students have wished us to teach. Okay, then I wouldn't like to make totally traditional versus distance education, but at least a little bit we can make some contradiction here. Okay, student-centered learning. It's a sort of cycle in our case, and I think mainly students can have some control and choice over the things what they are learning, and this naturally gives students responsibility of their learning, and this is at least in Defense University, we think this is very important, that students would understand they are responsible of their learning. And adaptability, which is in our understanding means active learning, continuously reflective learning, and we recognize diversity. In second course, we recognize it by asking students what kind of final works they want to do, and these final works were then were able to start them already in the beginning of the first week of this course. And there is cooperation between student and lecturers, of course, but mainly I would say that it's peer learning when they do their final work. So they mainly work together and only as groups, and only when they have some serious problem they ask from lecturers. Of course, in the beginning we all have to agree that this is suitable work, and that it's also that it's possible for them to solve, at least in some degree. Okay, then higher order thinking, of course, because this is research, so it comes all this Bloom axiom, higher levels, highest levels, evaluation, analysis, synthesis. They are all present here. Okay. Well, how is action research then connected to this way of teaching? Okay, so there is cooperative planning and peer-to-peer action, analysis in peer-to-peer and lecturer, and then conclusions, they are evaluated publicly. So not only to the teachers and students, but everyone can evaluate how they managed, which is also important. Nothing is worse for this military officers than public humiliation, and that's a good motivation. And flipped learning, how it works in COVID-19 context. Okay, so of course there can be, and we had them too, some little homeworks that which make students ready to do the final work. They also had some work which they were estimated to do before they come to our next lecture. And distance collaboration. So of course it's sort of naturally flipped learning, this distance education, because it's natural way of being distance, in my opinion. Okay, methodology course 1. It's in my opinion, of course, Antti can say, because I didn't really talked in methodology course 1. I was in teaching half of the methodology course 2. So Antti can comment that is this really how this methodology course went through. It looks very straightforward here. Perhaps we could have used other illustration. But anyway, lectures, illustrative demonstration, examples, pretty traditional. Voluntary and supervised practices in distance. This is after this teaching started to change, that yes, you should support distance education over this traditional education. And then finally there was formative test. Okay, that too is traditional way. A methodology course 2. It wasn't an accident that I made it to look almost exactly like student-centered learning circle. Okay, anyway, students chose their own final works, which of course automatically makes them to take responsibility of the teaching. And it also makes them active, because they immediately when they hear something what they could use perhaps in their final work, they start to ask that, do you think this chain theory could be used in this my problem, or this P method, could it be used, or Markov chains? Are they too complicated for my work, and so on. Anyway, they immediately it gives good conversations and so on. Learning becomes active and reflective, and this diversity has already been taken into account when students have been given to works which they have asked, which most of them were connected straight to their master theses. And then there is cooperation between student and lecturer, peer learning, and higher order thinking. Okay, they have to evaluate, analyze, synthesize this information what they have been given. And okay, student feedbacks. Blue one is from totally distant course, and because 5 was maximum, it looks like that we almost got what we say in Defense University North Korean statistics. But anyways, even also this verbal feedback what students gave, they most of them said that how would you like to improve this course. More than half said that I wouldn't change anything. So obviously they were happy about this. Most of them achieved goals. They were active in their own opinion. Ambience, so sort of environment was uplifting in this. Actually, I must say now that methodology course 1 also, those results are very good. When you remember that it's mainly mathematics, statistics, what they are teaching here, or what they talked here. Instructors were supportive. I think that was overall great for the course. I learned new things. I learned new methods, things. Okay, so whatever. But anyway, they learned new things, I would say. No. Evaluation was supportive. Okay. And overall grade for the course was everything looked fine. Actually, me and my other colleague, not Antti, we were very happy about this. Of course, Antti was happy about our good review too. Okay, final notes. Students takes responsibility over their studies in student-centered learning, which is, I think, very, very important in Defense University to make these officers to take responsibility of their own actions. If they don't learn this, they shouldn't be officers at all. Well, modeling has a lot of connections to daily life, and of course, this makes it easy if you teach mathematical modeling to select suitable tools or use tools suitably to solve or support solution for students' problems. So it's very, very proper area which can be adaptive for students and very student-centered. Okay, they liked students. I mean, liked student-centered way. Okay, we have to give some more attention how we can connect this theoretical subjects to, or how we can teach this theoretical subject in methodology course 1 to that they are talked more student-centered way and perhaps get better feedback from students by doing this. And perhaps they always our students want real life related examples, like But perhaps why not, if they make sense and they can be easily connected to this theoretical background. Okay, that was my final slide.
Thanks, Kalle. It was really interesting because it's anyway, it's different type and different level of institution, and your students, because it's a defense university, right? It's
yes, it is.
Let's say everything.
It's quite different from
quite different. Yeah, but anyway, at least I want to ask you, because not only in your presentation, but in some other presentations, and quite often we are speaking about students' responsibility for learning, for example, or student should be responsible, student is responsible for learning. What does it mean, responsible? Responsibility?
I think they should take responsibility. They should take responsibility of their own learning. So if it's only them who can learn whatever, you can't really force them to learn. So it's naturally, it's always their own responsibility, but make them understand that they are responsible. I think that's the problem.
Okay, because when we, for example, okay, maybe working with adults, it's obviously different, but anyway, for example, this semester I also had one group of master students, and let's say, yeah, the main opinion prevails. No, do not work so much, etc. It's difficult. It's yeah, very high workload, etc., etc. You know, it's this is somehow when we are thinking about responsibility, about responsible student, about his or her attention to their own learning, because he or she is learning for himself or herself. It's not for somebody else. It should be, let's say, my business, my added value. Yeah, it's somehow very relevant topic, I think. Okay, thanks anyway to colleagues from Finland. It's again, it's so pity that you are not here in Lithuania. Yeah, as previous symposium, but let's hope that next time maybe. Okay.
But it's again 2 years. You should have something for next year too. We will come.
Do we have Karel, our next presenter?
Hello. I'm turning it on. Everything.
Czech Republic. We are again returning to Czech Republic. Oh my God.
Yeah. I would say that's the work of RICHTEREK.
Okay. Please go on. You can.
So I'm trying now to share screen. Do you see my screen?
Not yet. Okay, now it's okay.
Okay. So I've came up with the so long name for my contribution. It's overview of participation in correspondence competitions of Czech Republic and Slovakia in recent years, with a discussion of possible positive and negative effects of COVID-19. So the outline of my presentation is that I will say something about me. Then what is correspondence competition or seminar for those who are not acquainted with these terms, and what are the differences to the other kind of competitions. And then I will discuss some problems with data and show some graphs with these problematic data, and show a comparison of pre-COVID and COVID year. And then I will discuss some topics which I think that are connected with with the current year and the challenges that posed. So about me, I'm currently an editor in the publishing house of Prometheus, which is publishing books of physics and mathematics in Czech Republic, and I'm PhD alumni of Charles University. And I'm also organizer of physics competitions of Charles Faculty of Mathematics and Physics of Charles University, and especially FICOS, the Internet Physics Competition in English, or if it's translated word by word, it's a Physics Correspondence Seminar, and also Physicalani and Physicalani Online. So I have my personal experiences with this as an organizer and also as a participant formally. So correspondence competitions or seminars, how it's called in Czech, there are many different kinds of them, and I found at least 42 or 42 categories, and there are probably even more, and so it's a bit difficult to describe it completely. So it's from primary to upper secondary students. It's usually, I know most of them are for lower and upper secondary, and the data collected is mostly from these. Often organized by other students for younger, for example, by university students for upper secondary students from high schools. Probably it's typical activity for Czech Republic, Slovakia and Hungary. I don't know about similar things abroad, but probably there are some similar things, but I don't know about them. And far as I know, the oldest and still active is KROMO from Hungary, and it's working for more than 120 years. And most of them are individual competitions, although there are some exceptions. And there are about many different subjects. I know mostly about mathematics, physics, and informatics, but there are also about chemistry, concerned about biology, geography, geology, economics, and formerly I know about some things about history, linguistics, or science. And formerly I'm telling about it because some of them are not anymore working at this moment. And how does it work throughout the year? Throughout the year, there are different number of series. It depends on the correspondence seminar, usually from 4 to 8 series a year. Participants receive from organizers the problem assignments. They are usually sent by post, or they look at it on the website of the competition. Then they have, for example, 1 month for solving it. They can find some things they need for the solution. They write down the solution before the deadline and submit it today, usually through some online submitting form or something like that, to organizers, and then organizers check these solutions and send it back with also feedback to the participants, and they award points and then rewards at the end of the year. So how it's different from Olympiads? It's that all series rounds are usually distant, and that there is no competition part which is organized at some place, and all rounds are equally national or sometimes regional, and there are no some consecutive different rounds like smaller geographic part than greater geographic part and so on. And there is also usually no elimination between rounds, so and the participants can join throughout the year and solve only some of the problems, and they receive the feedback and so on. And they're also different from other kind of competitions, which are team competitions. In Czech, there are náboj or physical line type. And these competitions usually are for 4 to 5 participants, held once a year or twice. And there is only a limited time for solving the problems, for example, 1 to 3 hours. And there is usually important the number, not the solution. On the contrary to these correspondence seminars, where it's more important the solution, the steps which they have taken for finding the correct solution or not correct. And the results are usually in the minutes after the competition, and there are at least another 10 of such competitions in Czech Republic and Slovakia. So notes about the collected data. They are mostly international. Yeah, I will give you the link for it. Actually, I haven't translated the page to English entirely, but I send it to. I think it's working. And yeah, and there could be some regional competitions. I don't know about them, or so the data is not there. The data has to be online on their website and from only the available years. Some of the competitions have available data about their participants, like how many of them were during some years, but they do not exist anymore. So they have, for example, in the series there is only 5 years of this competition, and some I divided into categories, and we take summary if they solve the same problems, and participants in more than one correspondence competitions is counted to all of them, because I don't want to break some privacy and solve some GDPR problems. And for the data for this year is only for the part of the year, because I've collected it in February and March and I haven't updated it. And however, I think that usually the most of the participants start to participate during the first half of the school year. So there should be, for example, 90-95% of the participants. But in future, it could be good to update it. And I've sent you the link. So this is the total number of participants. So you can see that the number is rising, but it's from the reason that how many categories or correspondence competitions are there. There are 42 totally. However, the last year, this year is 34, and as you can see, every year is a different number, because the data from some competition is, for example, from 2009 to 2012 and so on. And someone's raising hand or something. Okay. And there is also there are also big differences between the number of participants of the competitions throughout the years. As you can see from this graph, you can see that some correspondence competitions had only average for about 10 participants, and some of them have more than 200. So, and this is the graph I wanted to talk about mostly, and this is the average number of participants in comparison of pre-COVID to COVID, and the orange line is average for 3 full years before the COVID. Or I know that COVID came in 2020, but the number of participants should be almost the same during that year, and it could be compared also. But the very different year was the 2021. So as you can see, some of them are comparable, some of them have big differences, and I have noted some of them. For example, Jamalvova, which is mathematics for lower secondary schools, they have decreased by 81%, which is sort of strange in comparison to the others. And Biozvěst, this is biology, it's to 33%. However, most of them didn't decrease by more than something like 50%. Average decrease is by 17% or median by 21%. But there are also some competitions where the number of participants rose, like in KMS Alpha, Pikomat, or Výbuch. Výbuch is chemistry for upper secondary. And I don't know how much time I have. So I'm
1 minute. 1 minute.
How many?
Oh, okay, maximum 2 minutes.
Okay, so I'm getting to the pandemic effects, and I haven't turned on. So what could be the pandemic effects? Like these competitions are distant, so there is no problem for participation. But there were some problems with correction of solution sent it by post to pick them up and to distribute, for especially for those who haven't used before some electronic correction system, and then to return these solutions to participants. Absence of face-to-face contact was probably the greatest challenge. Although the competitions are online, there is no camp. Usually there is once or twice a year camp for the best participants, and one of the greatest motivation is participating in this camp, especially for those who participate for a longer time. And this had many connected effects, like that with no camp there is less organization about it, but there was also some experimentation with new kind of meetings and so on. But we had to cancel the camps and so on. And there was also problems with organization of meeting of organizers, and there were less frequent, and so organizers were not so much involved, and that led to another organization problems. And there are also technical problems with synchronous meetings, like we can see in every meeting. And also the participants should have had maybe more time, but it was not reality for many of them, and some schools wanted even more things than they are in school. So, and this is also another online activity, so that's not like attractive for them so much more. But for some gifted students, it was an opportunity to give more time to what they like. And also there were problems with funding, and since you thought that I had only short time, so maybe I had a lot of links, and you can ask me anytime on my email, and if there are any questions or.
Okay, thanks a lot. I think obviously we have all contacts. If it's not problematic to be connected and to communicate if needed. Please stop sharing your screen, and I do not see no questions in the conversation window. Okay, and next presenter. Do we have next presenter? Yes, I see. Again, Czechia, Czech Republic. What did that's that's good. I like Czechia. It's really active people. Good. Please, you can share your screen.
Okay. Can you see my screen now?
Yes. Okay. Full view.
Okay. So thank you very much. And hello, everybody. My name is Ondřej Vencálek, and I work at Palacký University in Olomouc in the Czech Republic, where I teach statistics. And so besides teaching statistics, I'm doing also some applied research in statistics. So it means I'm using statistics and mainly in applications in medicine or epidemiology. I'm also doing some theoretical research. It means development of statistical methods, mainly non-parametric multivariate statistics, but I will not talk about it now. And what I want to talk about is that occasionally I give motivation lectures of statistics for high school students. So I think this is a topic for this symposium. I also saw several presentations, and I see that many of the contributions contained kind of statistics. So I think this is a topic which belongs to this symposium. And why I'm doing these motivations for high school students. Actually, I wouldn't do that if I were convinced that the subject statistics is taught very well at high schools. So I think there is still much room for improvement, at least in our country. So maybe it would be interesting to discuss what is the situation in your country as well. Okay, so this will be or my lectures, my motivation lectures are rather use case. And my strategy is follows. I'm starting with something familiar to students. So at the beginning, I will recall what is a straight line and how can we describe it mathematically. Then I add something new. So this will be let's say statistical point of view. We will have some data. At first, it will be artificial example, but then we will move to something what we call real life data, and in very short time I'm able to show students that they are able to analyze data at least at some level, and that the results can be very interesting. So the topic of the data analysis is very topical. It's about climate change. So okay, I will go through my presentation or what I'm discussing with students. So at first I'm drawing very simple curve, straight line, and I'm asking them if they know how to describe it. They usually know that there is such an equation, with two parameters, A and B. Sometimes it's K and Q or something like that. It doesn't matter. Okay, what else they know? They know that the line can be described or is determined by 2 points. And for example, 1 point here, x1, y1, and 1 point here, x2, y2. So the points lie at the straight line. So the equation must hold for both of the points. So now they have to find how can they compute A and B. So it's very simple. They have 2 linear equations with 2 unknown parameters, A and B, and then they can compute, for example, A. They will subtract the second equation from the first one and then divide by x1 minus x2. Then, of course, we have to assume that these 2 numbers are different, so we don't have points at one with the same x coordinate. Okay, and then the question is, how can we interpret the parameter? Because it's very important to interpret parameters. And okay, we see that it's a change of y, which corresponds to change of x. So here we have change of y, here change of x. It's the same as if we compute change of y corresponding to change in x by 1. So here you can see that this ratio is the same as this ratio. Again, it has some interpretation in geometry, but the main point is that that A is characterizing change of y corresponding to the change of x. Okay, so the second part. Now we will have more points. We will have some observations. For example, we can consider 2 variables, body height and shoe size. If the person is high, he or she will have high size of a shoe. So there is some connection, there is some correspondence of the two variables. But can we plot a straight line through all the points? No, we are not able to do it because they don't lie at one straight line. So can we use line here? Yes, we can, but what will be meaning of the line? We can assume that there is something like average shoe size corresponding to some given body height. So if we use average, then it's one value for average shoe size for given body height. So now we have a function, just 1 point at y-axis corresponding to 1 point at x-axis. And this function might be linear. Okay, so now we can show how the data might look like. So I have here 7 data points, just which I have just for fun, and I'm encouraging students to plot the data. They don't need any software. It's just they can use their pencil and paper, and then can draw this kind of graph. You can see that here we have two data points with the same x-axis, the same x value, but different values at y. But we already explained that it's okay. And now, what will be the parameters of the line? Can we say it from the can we see it from the picture? Yes, we can. We can estimate them, and there are many ways. There are many ways how to do it. So, for example, we can say, okay, the height ranges from 165, this is the minimum, to 194. It's about 30. Let's say the range is about 30 centimeters, 29, okay, 30. And the values, the y values, ranges from 37 to 43. So it's a difference of 6. So the difference in y is about 6, corresponding to difference in x of 30. So 6 divided by 30, it's 1/5. So we are expecting that A might be about 1/5. Okay, and so we can say vice versa that change in x, when we compare two people which differ in height by 5 centimeters, they will probably have 1 degree of shoe size difference. Okay, then we can also estimate B. So just by looking at this figure, we can say, okay, the equation will be something like this. And unfortunately for B, we don't have a natural interpretation, because if we substitute x equal to 0, we will have parameter B. But okay, what does it mean? Height equal to 0. It's a strange. We don't want to say anything about people of height 0. So what can we do? We can make this new parameterization. We can say, okay, let us consider x star, which is x minus average height. And if we substitute to the original equation for x, then we will find that y is equal to a times x star plus some other parameter, b star. A is the same, so it doesn't change. And now b star has the interpretation that its expected value of y when x star is equal to 0, and x star is equal to 0 if and only if x is equal to c. So b star will be expected or average shoe size for the person with average height. And so it will have quite natural interpretation. Okay, but these were just toy examples. We need, and I want to encourage to use real life data. And so I'm using data which are available at the internet here at this site. You can find data on sea ice extent. There are data from Arctic and also from the southern hemisphere, but I'm concentrating on north hemisphere, so Arctic area. And the data, okay, here you can see how the Arctic area looks like, and these are data from May, so quite recent data. And you can see the white area which is covered by ice now, and you can also see something like a median from the last 30 years, or these are not last 30. I'm sorry, this is from 1980s to till 2010, 2020. Okay, and so from this FTP you can download directly the data. They are in a CSV format. It's a comma separated values, so a very good format of data. But unfortunately, in a Central Europe, we have slightly different convention, that we don't use decimal point, we are using decimal comma, and then the values cannot be separated by comma, but they are separated by semicolon. So it's a technical problem which can be solved quite easily, but what is important that the data can be shown in or visualized in Excel, which is available for most of computers, or at least some kind of Excel is available. And you can see the data. These are data not from May, but from October, because I'm usually talking about this with students in October. So for each year, I have one point which corresponds to ice extent in October. It's important that it's just for 1 month, because if I had data from each month, there will be seasonality, and I will have to deal with the seasonality. Okay, and then what I can do, I can ask students, okay, can you guess what will be the slope, what will be the parameter A, and then it's, let's say here we are about 6, here we are about 10, so it's 6 minus 10 divided by 40, because we had about 40 years of observations. So the slope will be about minus 0.1. Okay, and now they can very simply find the equation in Excel. This is for x from 179. Then we can shift for better interpretation. As before, we can shift to the middle, and we will obtain this kind of equation. And now the question is, okay, we have equation. What does it mean? Can you interpret it in practice? Okay, students usually say, here there is a minus, sign minus. So it means there is a decrease. Okay, and can you say more? What can you say about this decrease? What does this number mean? And
1 minute left.
Yeah, okay. And they will realize that because the original is in millions of square kilometers, that the area is about the same size as area of Czech Republic. So it means each year there is a decrease in sea ice extent, which corresponds to the area of the Czech Republic in average. So then there are many things what to do next, and my goal for this was to motivate students to promote statistics. How? By connecting known, new and interesting examples. And I'm trying to encourage students that they can do some analysis of real life data. And my aim for today's presentation was to encourage you to work with statisticians, to promote statistics. So thank you very much for your attention.
Okay, thanks a lot. Do we have questions? I see no questions, but really statistics, it's really important, not only to motivate, just stop sharing your screen.
Okay.
Not just only for motivating secondary school or high school students, but also for us as researchers, let's say in education and educational diagnostics. We need statistics, obviously, and statistical analysis. It's usually a very important component of research. Okay, and again, we're returning to Latvia. I see colleague is ready. Please.
Yes. Hello. Hello. Good evening. Good afternoon, everyone. It's really an honor to participate for me for the first time in the BalticSTE, and it has been a really fruitful experience for me. My name is Kārlis Greitāns, and I'm a PhD student and a researcher at the University of Latvia and the Interdisciplinary Center for Educational Innovation. So today I want to add to the body of knowledge about student conceptual understanding that we have about what we have heard a lot in these 2 days. And my article will be about science teachers' professional development targeted to promote student conceptual understanding, and it is a literature review study which we have made in cooperation with my scientific supervisor Dace Namsone. And so to begin, a few bullet points about Latvian education system to give you a feel why this research is conducted. So first of all, Latvian curricula is changing. There's a new updated curricula which is focused on 21st century skills and deep understanding of concepts as student learning results. It's being implemented from this year. In our previous research, we have observed differences between teachers' performance in teaching and teachers' knowledge. And also, we have rarely observed cognitively deep learning. So I must say that the teaching and learning is a little bit behind from the curricula. And if we are talking about teacher professional development or TPD, there are a lot of opportunities available for science teachers. Mostly there are state financed, but weakly or not linked to actual teacher performance and teacher needs. So this situation brings us to a larger research that we are conducting for some years now. And the aim of this larger research study is to identify teacher professional development needs and to develop according TPD interventions more to reach every teacher with specific needs. So we started this process with the analysis of curricula and specific school goals of Latvian schools. Based on that, we developed a teacher competency framework consisting of 13 criteria, and we have performance level descriptors for all of these 13 criteria that we have used in observations of teacher practices. And yeah, we have also compared these observations with the desired practices and also developed different teacher profiles that we can observe in Latvian schools. So yeah, based on these teacher profiles, the next step is the identification of teacher learning needs and, of course, appropriate professional development solutions, which, of course, should be measured at the end. So this study is more about teacher professional development solutions, what other researchers have described, and the measurement of their impacts. So yeah, this leads to the question of this research: how the criteria of high quality teacher professional development manifest into in-service science teacher professional development targeted to promote student conceptual understanding. Or basically, how does the science teachers should learn to promote student conceptual understanding. An overview about the methods. So we followed the systematic review approach described by Strauss and Corbin, and our search terms related to teacher professional development and student conceptual understanding, and the search was conducted in ISI Web of Science database, and we limited the articles to those who are published in the last 5 years. And we identified 59 articles, thoroughly read them through, and following our inclusion criteria, which are that these researchers should describe in-service science teacher professional development targeted to promote student conceptual understanding in basic education in primary and secondary school. We came up to 19 studies, which I will uncover more in detail in the following slides. So reviews and pre-service teacher education and other types of other forms of or aspects of teacher education were excluded. So if we look at high quality professional development, then we followed the guidelines and the criteria described by European Network of STEM PD centers. And these guidelines include 7 criteria of high quality science teacher professional development. And the systematic review approach describes that review has concentrated on a core category, and this time the core category was the teacher professional development to promote student conceptual understanding, which corresponds to the criteria number 5, that high quality science teacher professional development should address knowledge, skills, and attitudes relevant to the curricula. So the other 6 criteria were seen as subcategories that can vary according to the articles and according to the TPD programs that are described in the articles. So this categorization actually led us to more specific sub-questions. To be precise, how to involve participants in active learning in such TPD programs, how is long-term involvement of participants ensured, and other questions that I hope I will answer in the next slides. So let's jump to the results. And first of all, some statistics. Most of the articles involved mixed method approach there, and most of the articles came from the USA, and there were some single studies from Africa, from Asia. So actually that leads yeah, to some doubts about how successful these keywords were chosen, because there were no research from Australia or Europe. So yeah, probably a more thorough investigation should be conducted. So, but let's move to the sub-questions. So the first one, how to involve teacher learners in active learning. And actually two ways highlighted. And most of the studies focused on active participant involvement, where teacher learners engage in inquiry-based input activities in the beginning of the TPD program in a summer institute, which are followed by reflection workshops throughout the school year with opportunities to model the contents and to research their own lessons between these input workshops. There are some studies that confirm that also online TPD can be as effective, but with criteria that social ties are important and should be considered in MOOCs or other forms of online learning. But also another form of TPD, collaborative action research, was also described in few articles. So the next sub-question, how is long-term involvement of participants ensured? And actually most of the studies reviewed were quite longitudinal. 11 of them lasted for more than 1 year. The maximum I think was 5 years for a TPD intervention. And yeah, actually with such approach that we have an input workshop, then a month for implementation of the newly learned content, and then after the month another input workshop. Yeah, it's kind of way how to involve participants in long term, and yeah, it's actually a key criteria if you look at TPD that promote student conceptual understanding. How are participants' learning needs considered? Actually, only few of the studies described such practice that learning needs were identified and considered. But one of good examples was described by Miller and Castens, that before the TPD intervention, which focused on modeling-based inquiry, the developers of the TPD asked teacher learners where in their practice, in their curricula, they see the right fit for modeling practice, and according to these thoughts, they also planned the future TPD activities. How is transfer from TPD into practice fostered? Actually, there are two ways. One is to give ready-to-use classroom resources and to support teachers in the use of them. And another is a more open way of TPD, writing unit plans, writing lesson plans, with also the support by educators. But almost all the authors confirm that the personal touch to the TPD and the construction and modification by teachers of the TPD content are critical in achieving high levels of appropriation and participation. Yeah, and how then the scientific competence is developed and fostered. And actually, yeah, to develop student conceptual understanding, most of the TPD programs focused on inquiry-based approaches, on inquiry-based learning. The methods differed. There were some, there are a lot of articles that describe argumentation as a pathway to deeper conceptual understanding. There are some authors that mention modeling and also construction of explanations as classroom practices that promote conceptual understanding. And there are also some studies that say that actually conceptual understanding is a vital key element to form beliefs, which can later form into behaviors and actions to solve global issues. And the last of the sub-questions, how then are the impacts of TPD evaluated? And actually, almost all studies mentioned quite well-known TPD evaluation methods as labs and observations, participant and student questionnaires, tests, and lesson plan analysis, but there are also some more novel approaches, for example, analysis of teacher-participant concept maps, and also analysis of teacher drawings, how they see teaching for conceptual understanding. And to sum up, actually, a key finding, in my opinion, is that participant needs should be considered throughout the TPD, and first of all, it should be considered when planning the input, application and reflection phases of TPD. The participant needs must be constantly monitored through long-term involvement, and also should be considered to mediate the transfer of TPD into practice. And there are two conclusions: that a model that provides that combines input workshops with the monthly follow-up sessions during the school year is the most common one to promote student conceptual understanding. And also that the personalization is a key for successful TPD, which and of course, trusting cultures can be very powerful mediators that can develop teacher-learners' ownership of the learned contents. So thank you for the attention, and yeah, any questions? I'm ready to answer them.
Yeah, thanks a lot for your presentation. Obviously, this topic, what is related with in-service science teachers' professional development, it's really important and in any aspect. And just one simple, not maybe simpler, but just a question. You mentioned high quality science teachers. What does it mean high quality in your understanding? How it should be high?
Of course, if we look at any teacher professional development initiative, the main addressed is the student. In my view, every TPD intervention should give some impact to the student level and change student outcomes. That's first criteria, but also a high quality TPD, of course, needs to be effective. It should be relevant, concentrated on the teacher learners' needs to promote these changes in student outcomes as effective as it's possible.
Okay, but it's of course it's a deep discussion, but it's not maybe possible to directly connect teachers' professional development and students' achievement level. For example, because not maybe traditionally, if achievement level of students is not correct, not okay, for example, low level, it means directly that teachers are also not so good. It's not maybe direct correlation.
Of course, I agree to you. There can be some, how to say, other variables that impact this result. But yeah, actually we have made a lot of we try to triangulate the situation, our data to construct this teacher profile as precise as we can. So we take into account student results in statewide tests. We take into account lesson observations, teacher knowledge tests, and also teacher belief tests. So based on the, I would say, quite a rich data, we try to build this teacher profile and and address the TPD according to what we know from different sources of data. I 100% agree to you that student outcome isn't the only data that should be taken into account, but in the end of the day, probably the student performance is and changes in them. It's the main aim why we organize TPD in our view.
Okay, thanks. And I see in conversation window one question. Somebody says, "Good morning from Brazil."
Yes, okay. Good morning.
We are approaching
to
the evening time, but I do not see the question. Maybe it's possible to.
Okay, it's about genders in educational establishments. Yeah, good question, but based on this review, I cannot answer it because the research articles didn't focus on genders as variables. So there were some articles where actually in almost all of the articles the groups of teachers were quite mixed, and there weren't any differences between genders researched.
Thanks. Okay, and we have our last presentation.
Thank
and
you.
we're moving from Latvia to beautiful Maribor. Maribor sounds very well. To Slovenia. We discussed many times with Metka. Hello, Metka. About Maribor. Maribor, at least in Lithuanian understanding, from language point of view, it means like very secret word, Maribor. Okay, Betka, please start.
Do I have my presentation on the screen?
Okay, please share screen.
I have shared the screen. Do you see it?
Not yet. We are waiting.
Okay, I'll try again. And now?
Not yet.
Okay. And now?
Not yet.
Then I have to call for the help. Boris, noće mi naložit skrina. Noće mi naložit skrina. Noće mi naložit skrina.
Sorry, some small technical issues. I think we will solve somehow.
To Zoom.
Ne, Teams sem vam spomnil, če vidiš. Aj, sem bila.
Okay.
No, it's okay.
Okay, but full view, please.
Yeah. Okay.
Oh, now it's okay, correct.
Thank you very much. It is so good to have a husband, personal assistance with digital literacy competence. My team is today to speak about primary students' natural science digital literacy competence in digital learning environments. I'm just one member of a team comprised from Polona Legvard, who is my PhD student, and Maja Kerneža, who is my assistant. As Vicenta said, I come from Maribor, Slovenia. It is a nice place. You have 2 hours driving and you come to Vienna and can eat a sachar cake, and you have another 2-3 hours driving and you can drink coffee in Venice on San Marco market. So, what is about the primary students and their digital literacy? This study describes a research focus on primary teachers' evaluation of their students' digital literacy as a basic competence in the structure of natural science literacy of research and comprehension competence. It is the opinion about generation Alpha, the children of generation Z, which I will explain a little bit later. So, I hope you agree that everybody knew that educational system must change as a consequence of the digitalization process. We all knew that, but no one had imagined that the shift from traditional to digital would happen in an instant for all levels of education, for all students and for all teachers, as it did with the closure due to COVID-19 lockdown. The change in learning environments took place in different contexts. There were countries, school systems that were technologically prepared, and there were others which were caught unprepared. And in Slovenia, we were technologically prepared. our internet connections could handle multiple users per time, or at least they could after a week. Our students were equipped with computers and tablets, and if there were some students who were not, the instant help was there, and after 14 days every student had the computer or a tablet. And as we believed, our teachers were digitally competent to teach in digital environments. But in case of primary level of education, the students' digital literacy is and was a constant problem, even in digitally advanced technological and digital learning environment as Slovenia is. So, in the context of natural science didactics in digital learning environments, the critical question of primary level natural science education, besides the basic literacy, the problem is students' natural science digital literacy competence. There were two aims of our study. The first aim of the research presented in this presentation was to find out if and to what extent digital literacy of Generation Alpha is advanced in comparison to the digital literacy of Generation Z. Let us clarify. Generation Z are millennials, children born after the year is named differently, but at least after 1995. Generation Alpha are children from Generation Z. So children or young people who grew up in a digitally advanced learning environment, opposite to Generation Z, who had, let us say with Mark Premski, digital immigrant parents. The second aim was to find out whether the digital literacy of primary students reaches the level that can be used in the context of natural science digital competence for successful participation in social constructivistic-based natural science class. To find the answer, we formed the following research questions. Firstly, according to teachers' assessment, how high is the level of primary students' basic computer literacy, the basic competence of natural science literacy of research and comprehension competence? Secondly, which digital learning environments did teachers use for science teaching during school closure in Slovenia? Thirdly, how many natural science curricular goals were reached in these digital learning environments? And fourthly, which natural science curricular goals were not reached in the digital learning environments, and what are the reasons why teachers did not choose them during distance teaching in the digital learning environment? The research background for establishing the difference progress of digital literacy of Generation Alpha compared to the previous Generation Z, was the study conducted in Slovenia in spring 2015, which was introduced in Šiauliai in the next year, so in the year 2015. This study examined compulsory and secondary school natural science teachers' assessment of their students' new natural science literacies of online research and comprehension competence. The first column, or the first research group, the first part of the sample were students of age between 6 and 8, which is first triennium of primary education in Slovenia. So we took this data to compare them with basic digital, basic computer literacy of Generation Z. A sample comprised from 176 primary teachers in Slovenia was quite good because, as mentioned, the first three criteria for successful teaching in digital learning environments are in Slovenia of quite high quality. So, because all of these factors usually occur together, in Slovenia, this is not the case. In Slovenia, technology factors were solved very quickly. Teachers were prepared to use digital learning environments in many projects. Consequently, Slovenian primary teachers are a reliable sample to find answers to the listed questions. Which instruments did we use? The first set of data was collected using the 20-point Likert type scale questionnaire, and the items were adapted from the TICA checklist formed by Donald Liu in year 2008. We adopted this checklist and used for our study 21 of 29 items in the computer basic checklist. The second set of data was collected through the online questionnaire learning environment for the first 3 grades in the time of remote teaching, which contained 22 questions regarding teachers' experience after COVID-19 school closure, which was, according to our media, the longest in Europe. Then we analyzed this data with IBM SPS program, and here are the results. These are, according to Donald Liu, the structural elements of computer basic skills. Here we see the results of generation 2015. Here you see the results from generation alpha, which were collected in 2021 in first week after children return to school. So after this long period of remote teaching. We will not go into the details. You will be able to see this in the paper. But on the first side, we can see that the computer basics did not improve much. That only the computer basics are quite sufficiently there, but any further use of computer, any further use of tablets, if we remove the gaming from our point of interest, is very, very, very low. My comment to this data would be, there is no wonder that parents of small children age 6 to 8 complained over the workload they had with their small children. And I don't know how it was in your country, but in our country there were protests. Not protests against wearing masks, but protests against the closure of school, protests against school teaching. The parents and children demanded returning to school. Here is the other set, the second set of results, and you see primary teachers' responses to the question in which learning environments did they teach during the distance learning, distance teaching school period. And you can see that the majority of teachers were teaching in online learning environment and in via social networks. They only used phone calls if there were some problems and if they couldn't reach some students or some students. So the interesting part, how many science curricular goals did you reach during the remote teaching period? Was the question, one of the questions addressed to the teachers. And as you see, no one reached all the goals. No one reached all the goals. Only one third of teachers reached almost all goals. 3/4 of teachers, 26% of teachers reached 3/4 of curricular goals. Okay, these are interesting data, but we wanted to know more. We wanted to know, or we wanted to find out which goals did they reach with good learning outcomes, with good learning results, and which are these goals which they chose not to teach because they thought it would be impossible, or which goals did they teach in the digital learning environments, but then after that they found out that the learning results were not sufficient. We didn't want general answers, so we asked teachers, firstly, make a list of 6 topics you think they were very good managed in the digital learning environment. And then after that, make a list of 6 curricular goals which you didn't teach in the digital learning environment, or you did teach them, but you didn't reach the learning outcome you expected or you wanted. And what was dramatical in these answers? You know, in Slovenia, the subject science in the first triennium is comprised of topics from social sciences and of topics of natural sciences. And about very successfully implemented curricular themes in the digital learning environments were almost only social science goals, perhaps here and then 1 or 2 from the field of biology. And on the list of less wanted, less chosen curricular topics were almost exclusively topics of physics and topics of chemistry. We wanted to know why. So why not selecting natural science goals, or which natural science goals were unachievable, and what is the reason? And the reason was, as you see, very often chosen, distance learning requires a different didactic approach and limited students' digital competence, and very, very, very rarely my limited digital competencies. So if we discuss this result, the results from our research are consistent with previous research gained in the meta-analysis by Delgado and his team. In his research, in their research, they found no difference between age groups across the 17 years by the results obtained in later research. So in their research, the results obtained later show poorer reading and learning outcomes in digital environment. It is not getting better. If we if we think about tablets in the children's room at the age of 6 months, and this is consistent with our findings, showing that contrary to expectation, primary students, Generation Alpha, do not have sufficiently developed digital competence to participate effectively in digital learning environments, which presents a major challenge for primary teachers as for us, for our research, because we have to find out how to perform the natural science class on the primary level. In conclusion, a call is needed for researchers, policymakers, and educational experts to develop methods that support effective digitally based natural science teaching and learning in digital learning environments for very young Generation Alpha students who have a very limited digital literacy skills in addition to their still emerging general literacy skills.
Thanks, Matka. If I understood, you finished your presentation.
Yes, I finished my presentation.
Oh, it's okay. It's really nice and interesting as usual. And maybe colleagues will raise some questions. At least I again want to return to one important issue, because you mentioned also remote teaching and learning, let's say, format or model or mode. And anyway, there is really big difference between so-called traditional or conventional modality, remote education, distance education, distant learning modality, and emergency remote teaching modality, which was caused by pandemic situation. And let's say we were not prepared for that. And for example, speaking about university, it was obligatory to move immediately full study process remotely, to conduct remotely. And this was not, let's say, distance learning modality in our classical understanding, but it was emergency modality, emergency remote teaching modality. Can you explain shortly from your perspective?
We tried to help. I'm not speaking about the study process on the university. I'm speaking about university students helping to teachers. So because at the university there are some young researchers who are exploring this field, and our students are educated in natural science teaching in learning environments. And when the schools were closed, we offered help to teachers to connect with our students. So the apprenticeship of the previous year was performed in the form that our students somehow connected with teachers to offer their help. It was not formally. We did not give them guidelines. What do they have to do? We said, try to help wherever you can, wherever needed, and try to transfer your ideas and your knowledge you had gained at the university into the school reality. And the responses were very good. Not only that, our students were very confident and very pleased that they could try what they had learned at the university concerning natural science didactic in digital environments. Also, teachers said that the students were of the great help, that they had get a lot of knowledge they could immediately use in practice or in that circumstances. So somehow we tried. We do work on this subject, in this field, and we really tried immediately, not to wait they will graduate and they get a job and get there. We send them there immediately.
Yes, it's understandable. However, when we are speaking, as I said again, about regular distance education, regular, traditional, we are prepared in advance. I mean, not only content, of course, study content, teaching content, lectures, teachers, infrastructure, ICT support, etc., etc. We are preparing, let's say, remote courses, modules, etc., etc. But in pandemic time, let's say, we moved from regular, not online, from regular face-to-face teaching mode to remote teaching mode, emergency remote teaching mode, and this is different from regular distance education. This was my point.
I think we have to take seriously the DigiComp Edu paper, you know, to develop digital competence hand in hand with subject didactics, because this is the only answer. This is the only way we find really useful and correct answers.
Thank you. Okay, colleagues. Well, it was the last presentation. It's a pity, of course, but we are approaching to the end. This is our life symposium. I hope it was more or less successful. We gained a lot of different knowledges, different ideas, etc. And I want to, let's say, for next 10 minutes maybe, or maybe more if you want, it's up to you. And to divide this part, this next discussion together, to combine with some so-called closing, symposium closing, and into two parts. First, let's say, short part, more or less official part, I want to speak about something about symposium, about this symposium, and maybe about our future. And next part, let's say, absolutely flexible, free for discussion among colleagues for some time, if it's up to us, obviously. But after this first part, I will stop recording. Officially, we will close symposium. Again, I think that despite some small, really small technical issues, we were able to manage this symposium. Fourth symposium, you remember that we started in 2015. After a short period, short interval, because in reality we started in 2006 with ICT conference, international ICT conference in frame of international RISE project. I think some of you remember very well. It was connected with augmented reality. At that time, we worked, our team worked, and we were deeply involved in this project, in augmented reality project. And after some conferences, after generally 4 or 5 years, we finished with this ICT conference and turned to our Baltic Baltic Symposium, first of all, having in mind our region, our 3 Baltic states and states around Scandinavia, Poland, Central Europe countries like Czech Republic, Slovakia, etc., and moving next to Balkan. And I remember we discussed with colleagues from Slovenia that why not to have a symposium not only Baltic but Baltic and Balkan to be symposium connecting Balkan region and Baltic region. But anyway, this symposium is open for everybody. I think it's also important. But the idea was to show, to emphasize our work, our practice, our experiences, to share these experiences, etc. I hope so. At least we fulfill this our main purpose, and at least we're following it. I'm not sure, obviously, this previous year and this year showed that our life is really unpredictable, and the idea was to meet physically, face-to-face again here in Lithuania in June, in let's say in middle of summertime. It's very, of course, it was not possible. And speaking about next possible symposium, maybe again I am not sure, obviously, let's say in 100%, but we hope that after 2 years it will be possible to have our next 5th symposium 2023. Let's hope without any pandemic, and it will be possibility to meet again here in Lithuania from different parts of the world, and to share our experiences and to communicate, etc., because this is invaluable, very nice possibility. As I mentioned many times, you can follow us on Facebook, our center Facebook account. Regularly we are updating with different information related to new journal issues, new news, new articles, new papers, some events, etc. And if you have such a possibility, you can you are welcome to follow us on Facebook. At the same time, I want to remind that we have continuously working symposium website, BalticSTE2021.com. This website is let's say updated, and we want to keep it updated continuously, and we will try also to put the latest information related to this symposium and maybe to some further activities. At the same time, you can find on this website proceedings of from previous symposia, and to download, to read it, because we started let's say to index our proceedings in some indexing services. Currently I uploaded in conversation window, you can find a link to Central and Eastern European online repository, CEOOL. All materials, all proceedings starting from 2015 are available online. You can share your individual paper if it was published, obviously, and you can find easily individual paper to cite properly, etc. This is available in this Central and Eastern European online library. And the next proceedings from this symposium obviously is on the progress. We are working on it. We received approximately 15 proposals, 15 papers, manuscripts. The first review round is finished, and we are awaiting some obviously improvements, etc. And we hope that we will manage successfully, and we will publish useful and interesting proceedings also online. It will be available on Central and Eastern European Online Library, also in some other indexes, and possible in ProcQuest database, because we have some contacts and preliminary agreement with ProcQuest database, and I hope so. All proceedings starting from 2015 possible will be included also. You can find this is not finished just on the spot. If you would open BalticSTE website, this is very small information about indexing. Just on the top menu, indexed by, you can find this information related to our previous symposium proceedings. And at the same time, you can find contacts. Obviously, we use a Gmail account. It's possible to contact at every time if you want, because it's available. At the same time, it's possible to contact directly to my personal email account if needed. And let's keep, I want to say, our family, our big family, international family alive, and in order to be maybe prepared for next symposium, for next meeting. This is approximately all what I wanted to say at the end of this symposium. Many thanks for all of you for your, let's say, really responsibility, your good and positive attention to it, who managed to work these 2 days and to be with us. It's fully understandable that we are sitting at home or whatever else in workplace. It's not so easy to be continuously from the morning to a whole day. We have obviously different needs, different interests, different activities, and maybe it was not possible to follow in full. But anyway, we have, let's say, good technologies, and as I mentioned again, the symposium is video recorded, and all video files will be uploaded on Facebook and maybe later on YouTube channel. In any case, I will keep you informed what is related with our symposium. Okay, once again, many thanks for all of you, and with my official speech is, let's say, finished. Many thanks to our colleagues who supported us, I mean members from organizing committee, at the same time members of scientific academic committee, because it's also very important, and let's say together we were able to manage somehow. Obviously, it was obviously it was a little bit confusing, because, as I mentioned during first day, during opening, for a long time it was not possible to reach a final decision about the symposium, to go online or to postpone to the next year, as I mentioned during opening. But finally we decided to have it online. Why not? And in order to keep our time frame, etc. Okay, and I am stop recording right now.